So, hello everyone, how are you all? Hi everyone, hello, welcome everyone, how are you all? Am I properly audible and visible to you all? Do let me know in the comment section. Yes, beta, how are you all? Yes, so myself Gunjan Goyal, your chemistry educator, and for the thing you all were waiting for, that was your backlog coverage. Many of the students texted me that, ma'am, we are having the difficulty in finding out that how to recall the chapter that we did in our last few days back, and how to compensate the time that we have wasted just to do all our other works, right? So here I am to make you the concept much more clear about the chapter, some basic concepts of chemistry. How are you all? Welcome everyone. Very good evening, Avanta. Keen, okay. Lahari, welcome beta. Welcome, welcome, welcome. Niharika, welcome everyone. Okay, so myself Gunjan Goyal, yes beta. You can simply say me Gigi ma'am as well. I am here to help you out with the chapter some basic concepts of chemistry. Let me tell you the lecture flow, how to attend the lecture whenever you are attending my session. I make my students that the concept will start from basic and we will parallelly move till advanced, right? And we'll make sure that all the concepts that we cover so far there in the chapter, they all are clear to you all. So yes everyone, do let me know that in the chat section by clicking that like button, that whether you are attending the class or not. For the students who didn't hit that like button, just immediately click it out and mark your attendance so as to get to know that how many of you are actively participating there in the session, how many of you are active in the session, how many of you are activated, motivated and are ready to boost the lecture. Yes beta, very good evening, very good evening. G ma'am, yes. Yes, yes, yes. Okay. Yes, everyone. Yes, your GG ma'am is back now in the channel that is PW NEET English. So I want you all to be active. First of all, starting there with the chapter with the hi-fi emoji. Yes, I want you all to give me that hi-fi emoji, that yes ma'am, the higher fire heart emojis, to get to know that yes ma'am, we are attending the session, we are ready now, we are super excited now because your GG ma'am is very much excited to teach you all that in this platform, right? Very good evening, very good evening, very good evening. Yes ma'am. Okay, yes, I am teaching that in the batch as well beta, in the PW NEET English only. Yeah. Okay, so starting up with the session, what we gonna discuss in today's class is all the chapter concept that is required there in your chapter. Beta, we will start with the basic terminologies, basic terms. We will start with the basic terms, basic terminologies, basic terms like what is atom, what is molecule, what is homogeneous compound, heterogeneous compound. These all type of terms we will get familiar with. Then we will do discuss about the concept of atomic mass, that what is atomic mass, what is atomic mass, right? What is the representation, what is the symbolic representation, about the mole concept, about the mole concept, about the stoichiometry concept, about the stoichiometry concept, about the stoichiometry concept, about the limiting reagent concept, limiting reagent concept. So these topic parallelly along with the laws of chemical combination, laws of chemical combination, we gonna cover them all there in our class. Okay, so be ready. Okay, be ready. Yes, I want you all to like the session firstly, so as to mark your attendance. Yes ma'am, we are attending GD ma'am's lecture. Okay, do share it with your friends as well. Be ready. Yeah. Okay, starting up with the session. Yes, so first of all we will do discuss about the chemistry, because this is the first chapter of your chemistry. Many of the students, because this is for Arjuna, yeah, I know that many students find the difficulty of getting the base to be much more clear, right beta? So we are starting with the basic portion, that why we are studying chemistry. Chemistry find multiple applications, right? Chemistry is showing multiple applications, multiple in the sense we can know that fertilizers, agriculture, in agriculture field we know the fertilizer, pesticide, insecticide, weedicides, multiple chemicals are used, right? They all are chemicals only. So they found very much importance there in your agricultural field, right? In the preservative, like sodium benzoate is preservative. So in the preservation, we can say fuel petroleum industry also do use the chemicals only, like the diesel, kerosene, oil and all, right? Now you are familiar with the ethanol term, right? Yeah, because they are in the vehicle, we do use the different percentages of ethanol, right? So here we can say that chemicals are used in the fuel industry, right? Moving on to the war, we can say TNT, trinitrotoluene. What is it? It is a chemical only. So in war also, mustard gas, Bhopal gas strategy, they all are the different chemicals that are used for different purposes in your day-to-day life, right? We are very much occupied by the chemicals only, chemical components only. In the household, we do have cements, that is chemicals only, right? The manufacturing portion, the shelters, complete shelter that we have, all of them comprises the chemicals only. Chemicals are used in the health industry as well, just like the different type of pharmaceutical drugs do we have, right? The antipyretic drug, anti-malarial drugs, anti-fertility drugs. So these all are antimicrobial drugs. These all are the drugs that are what? Beta, that are chemical only. So chemistry play a very vital role there in our environment to make us sustain there in the life, right beta? This is about the basic terminology about chemistry, right? So beta, in chemistry, what we do discuss that chemistry, for a chemistry person, if I do ask you about anything, like this is a piece, okay, of any matter that is there in the in front of me. So if I ask you that for a chemistry person, what will be the composition, like what is the thing that is creating this stylus, right? What is the thing that is making this stylus? What is the structure of it? How this marker, this stylus will respond when I change the temperature, when I change the pressure condition, okay? So how it will react with different type of substances. So in chemistry, we deal with all such type of things. Correct? Simple, ma'am. Very much clear to us that in for a chemistry person, what is the basic chemistry term? So chemistry is the branch that deal with these type of things only. What are these? These are the study of composition, that with which substance are the particular compound made from, properties and structure of matter, changes that the matter undergo under different condition, and all the laws that are governing how it is changed, right? So basically we can say that chemistry is the branch of what is the branch of atoms and molecules. Now ma'am, we are not that much familiar with atoms, molecules, matter. Please help us to distinguish them all, right? So I am there to help you all out only. So we are now making the term much more clear, matter. So beta, before I start with, I am asking you that do let me know that what do you mean by matter? What is matter according to you? Do let me know in the chat section. I'm reading your chats only. Do let me know that what do you mean by matter? That what is basic definition of matter? What you have learnt about matter in your lower classes? Okay, no 10 issue beta. We just started the class now only. So if you join now, there is no issue at all. You will be able to cover up with the pace. Yes. What is the meaning of matter beta? Anything that occupy space. If I ask you about matter, what is matter? Beta, what is matter? Matter is, ma'am, just a simple term that we use for a substance that occupies space. Yes, that have mass. I want you all to communicate with me there in the class by just texting your answer through the chat. Yes, very nice. Who was that? Which we can see matter. Okay. Prince is telling me this thing. Okay. Jeevan Raj is telling me anything that occupies space and have mass. Absolutely yes. So matter is a basic term that we use for a substance that occupies space, right? That do contain some mass, that do have some volume, right? That do have some density and so on. So matter is something that occupies the space, right? Do have some mass. We can consider air to be matter, yes or no? We can consider table, chair, pen, water, whatever the thing that we see around us that we cannot see like air, but air also considered under the category of matter only, beta. Yes or not? Because air do occupy the space. In the studio also, I can see the space that is covered by what? What? Air. So occupy the space. So air is what? Air is matter or not? Yes, ma'am. Air is matter. Water is what? Matter or not? Yes, ma'am. Water also do occupy space. So water is also matter. But your emotions, simple thing, emotions, whether emotions are considered under a category of matter or not? Yes, beta. Very good. Very good, Prince. Very good, Ravi. Very good, Jeevan. Very good. Very nice. Yes, this is the spirit I want my each and every student that is attending my class, irrespective of whether you did your chapter in the last portions or not. But right now, whatever I'm telling you, making it very much clear to you all that you guys gonna enjoy the session till end, because the session duration is approx 3 hours and we gonna cover the session in 3 hours, the complete chapter in 3 hours, making all the concept that whatever we did in the chapter to be much more clear to you now. Okay? Yes. Okay? Yes. Okay, beta. So yes, what is matter? Emotions, whether we consider emotion as matter or not? No, ma'am, not at all. Emotions are not considered as the category of matter because it is not a matter. It do not occupy any space. It is not, you can say, matter. Okay, yes, ma'am. Now, what do you mean by atom? Some basic terms. What do you mean by atom? Atom. Atom is what? Beta, what is atom? Atom is what? We can say the basic unit of matter. We can say it as the basic unit of matter. Basic unit of matter. Basic unit of matter. Right? That is indivisible. The basic unit of matter that comprises, right? The atom actually combines there with each other, and overall form a huge structure that is matter. Right? So matter basic unit is what? Atom. Right? We will divide the matter in certain pieces, and the last piece, that is atom only. Now, what is the meaning of molecules, ma'am, then? What is the meaning of molecules then, ma'am? What is the meaning of molecules then, ma'am? So, beta, molecules is nothing else. It is just the atom combining there with each other to form the stable structure that is molecule. Let's say H and H. These two hydrogen atoms combine there with each other to form H2 beta molecule. H2 molecule. Right? Hydrogen atom, oxygen atom and hydrogen atom, they all combine with each other to form H2O to be the molecule. So these are molecules. That atom combine each other to exist in an independent state, that is molecule. As simple it is. Is that clear to you all? I just want you all to parallel note down the whatever notes I'm writing over here. You just have to create it parallelly along with me, so that afterwards you can easily take a quick recap of whatever thing we did discuss in the class. Beta duration is of 3 hours. Okay, we will take the class, approx duration is 3 hours, and in 3 hours we're gonna discuss the questions, we're gonna discuss the concepts, we're gonna discuss all the tricks that we're gonna use in different type of question that is very important for you all in your NEET competitive examinations. Okay. Okay. Yeah. Shall we move? So these are the basic terms. We're making it much more clear. All right. Now, if I do ask you about the matter classification, beta, matter is classified on two bases, depending on the physical nature or the chemical nature, whether we are dividing it on a physical basis or a chemical basis. On a physical basis, we already did discussed it in our classes, right? That physical classification of matter is solid, liquid and gaseous states. We are having 3 major states, although we do have other states as well, but 3 major states: solid, liquid and gases, depending on the particle orientation, how they are arranged there with each other. Then we do have chemical classification, beta. There in chemical classification, in chemical classification, we do discuss that matter is divided into 2 main categories, that is pure substance and the mixtures. Beta, in pure substance, we have same type of particle. We do have same type of particle. But what is the meaning of same type? What is the meaning of same type? That means there is no any other type of particle How, ma'am? We do divide the pure in two different forms, that is element and compound. What is these two and how they are making them as pure? See beta, same type of particle. If we do discuss about elements, element example is, let us say I'm talking about sodium element. Okay, I'm taking the example of sodium. So over here I do have sodium particle, sodium atom, sodium atom, sodium atom, sodium atom. So all the particles are that of sodium only. I am not having any other type of particle in this. All the particles are that of sodium only. So this is element where all the atoms are same only, right? All the atoms of an element are of same type only. But if I do talk about compound beta, so compound over here contains the element to be like combined together to form the compounds. So when we have two or more than two type of element combined to form compounds, let us say the example of H2O. Beta, over here H2O forms a complete particle. So here I do have the particles of same type only. That is why I am categorizing this into pure substance. So here I do have H2O, 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 H2O. That means all the particles are that of H2O only. There is no other particle at all in it. Right? So this is about compound, this is about element. Both are categorized as pure substance because we don't have any other impurity in it. If I do ask you about mixtures then, so I'm taking the same example of H2O only over here. Let us say these all are the particles of H2O, but in this H2O I do have some impurity. What impurity, ma'am? Let us say I do have some particles of, let's say, salt NaCl in it. So I am having over here two type of particles. So this is a mixture. This is a mixture. All right. So compounds, we can further subdivide it in two categories depending on the type of element that comprises the compound. Right, beta? We do have the inorganic compound. We do have the organic compound. In organic compound, the compound majorly comprises of carbon. Main carbon compounds are considered as organic compound. There are some exceptions, but we will discuss that in organic portion. Here we do have two type. I want my students to do let me know in the comment section. And for the student who didn't like the session, who didn't click that like button, firstly click the like button so as to mark your attendance there in the class. Very good evening. For the students, I can see over here some students are asking about my name, right? Yeah, so if you want my name, let me clear you. Myself Gunjan Goyal, who will be teaching you chemistry from today itself. Right? On the YouTube channel, you can see me. On the paid batches, you can see me. I'm teaching that to you there in the English platform. Beta. Okay. So, yes. Okay. So, attendees, all the attendees, just hit the like button and do let me know that whether the concept is much more clear to you now or not. One student is asking that different type mixture with each other is called mixture. When different type of particles, beta, when different type of particles are mixing there with each other, then they form mixture. Let's say H2O, NaCl, these are mixing each other. Different type of particles are mixing there with each other. It will form a mixture. Now the mixture is categorized into homogeneous and heterogeneous. Homogeneous means they have the uniform composition. What is the meaning of homogeneous mixture? They do have the uniform composition. What is the meaning of uniform composition? That they are uniformly divided. How, ma'am? Beta, we can say that example over here to be like, one second, example of it to be like salt in water. Salt in water. So here salt in water is what? Salt in water is what? Beta, salt in water is what? Salt in water. We are dissolving salt in water. So it is forming a clear, uniform mixture where we do not distinguish salt from water. Right? So this is a basic terminology that we do discuss in our lower classes as well. But I want my student to make familiar with the terms. Okay. Yes. If you want me to take live, one student is asking, if you want, ma'am, will you do live to other chapter from chemistry or you do only today? Okay, so one student is asking me whether you gonna continue the other chapters as well. So yes, beta, We will do cover other chapters as well. Whatever chapters you guys demands from me, I am there to help you out. Just text me. You can put your queries or doubts or anything. Then in the comment section, I will read, my team will read, and we will there to help you all out with all of your doubts, all of your problems. We are there to help. Okay. All right. Heterogeneous mixture. But in heterogeneous, what is the meaning of heterogeneous? Is non-uniform composition. Non-uniform composition. That means the components over here are not evenly divided. Let's say salt in water, sand in water, clay in water, right? So these all are making a non-uniform composition mixture, that is heterogeneous. Okay, all right. Is the thing clear to you all? Yes or no? Yes. Okay. In inorganic compound, we do discuss about the compound other than carbon, and here we do discuss about the carbon compound. So this is a basic category. I want to make my student much more clear, much more familiar with these type of terms that we subsequently use there in the forthcoming portion. Okay. Yes. Okay. Hit the like button, beta, and always communicate with me through the chat section that yes ma'am, whether the concept is clear to us or not. Okay, so keep on telling me there in the chat section that yes ma'am, the concept is all okay, the concept is chamka to us. Okay, yeah. Moving on to the basic theory portion. Dalton atomic theory. This theory states us many things about the atom, although there is many failure about the theory. We will discuss that in the next chapters. So Dalton atomic theory, what the theory states, that all the things, all the matter, as I told you, made up of what? All the matter is made up of tiny indivisible particles known as atoms. Very simple, ma'am. Atoms of an element, as I told you, are same, right? Identical. In what sense? In mass, size, and all other properties, they are completely identical. Whose elements? Whose atoms? Atoms of the elements. But if I do ask you about the atoms of different elements, they are different obviously, because they are of different elements, right? Hydrogen element atom is different and oxygen element atom is different because they do have the different properties. All right. Atoms can neither be created nor be destroyed. They are in a chemical reaction, right? Yes, we all know about it. Other atoms indestructibility law, what it law basically states, that atom can neither be created nor be destroyed. Yes, they can be just rearranged, they can be just combined, they can be just separated there from each other, but we can never ever separate, we can never ever destruct, we can never ever create the atoms. Okay, all right. Then moving on to that atoms of different elements. Students, here we have to know the concept that atoms do combine there with each other, right ma'am? We know about it, but the combination is specific. They always combine in a fixed whole number ratio, right? Yes, there are certain limitation of these postulates. I will teach you, I will tell you that what are the exceptions there of this Dalton atomic theory. Many of the exceptions are there from many of the postulates, but over here we will continue with the topic itself. Okay. Okay. Shall we continue then? All right. Now moving on to another topic, that is atomicity. What the name itself indicate? Yes, ma'am, we are very much familiar about atomicity. We might have learnt it in our class, I guess, 9th. Yes. Yes. So here, what is the meaning of atomicity? That is the number of atoms in a molecule. Depending on the atomicity, we do discuss about monoatomic molecule, where we do have only one atom. For example, He, neon, they all do have only single atom only. Sodium, single atom only, right? If I do ask you about diatomic is molecule that contains two atoms. That is, the atomicity is 2. Atomicity is 2. Atomicity is 2. If I do take an example, we can say N2, O2, CO, H2, NO. These all are what? Br2, Cl2, F2. These all are what? These are diatomic molecules. The atomicity, number of atom in a molecules are 2 only, right? Yes. Okay. Alright. Moving on to the one that contain 3 atom, triatomic molecule. So my dear students, triatomic molecule contain 3 atoms in it. 3 atoms in it. That means the atomicity is 3. Atomicity is 3. Now the 3 atoms can be of same type or can be of different type. Let's say O3 is triatomic, CO2, CO2, NO2, N2O, H2O, they all contain how many atoms? 3 atoms. Similarly, tetraatomic, right? Tetra stands for 4. Tetraatomic, that means we do have 4 atoms. Atomicity is 4. For example, we can take it for P4. Right, everyone? SO3. Tetraatomic. Overall number of atoms containing the molecule is 4. Alright. Okay. Yes. CO3. CO3 is in ionic form. So we can say that it is an ion. Alright, beta. So if I do ask you about a molecule for say C6H12O6, if I give you the question, students, C6H12O6, right? First of all, tell me whose formula is this? C6H12O6. Whose formula is this? Whose formula is this? Very nice. Charandeep, very nice, very nice. Keep going, beta. Very nice. Atomicity is defined as the total number of atoms present in a single molecule of an element, substance or compound. Very nice, Ravi. Well stated. Keep it up. Yes, keep the pace same only. Also, students, whosoever is joining our class, do share the session with your friends. Try to attempt max question. If you didn't like the session as of now, just click the like button so as to mark your attendance that you guys are literally attending the session. Yeah. Glucose, not only, yeah, many of the students marked it as glucose. Yes, obviously glucose do have this formula, but yes, many other elements like fructose also do have the same formula. We can say the other glucose similar member isotopes do have the same formula, right? Okay. So C6H12O6, here we do have for say this is the formula of glucose, where total number of atoms, what is the atomicity there? Atomicity, how many atoms are there? 6 of carbon, 12 of hydrogen and 6 of oxygen. So overall I do have how many atoms, beta? Total number of atoms are 24 over here. So atomicity of glucose is 24. As simple. Okay. Yes. Alright. So this is about atomicity. If I do ask you one more example, for example, do let me know, beta, in H2SO4, what is the atomicity? What is the atomicity? There in the chat section, we'll see that how many of you are giving the correct answer. What is the atomicity of H2SO4? What is the atomicity of H2SO4? Tell me. I want to see that how many of you are actually getting the concept, are actually telling me the correct answer. But keep on trying. Don't worry if you don't able to answer the question. That is also fine. But actually you are trying your level based. Okay. So yes, in H2SO4, how many atoms do we have? Simply, we can see over here that 4, 5, 6 and 7. We do have 7 atoms. 2 of hydrogen, 1 of sulfur and 4 of oxygen. So that will be the atomicity of it. That's simple. Okay. Yeah. So atomicity point is much more clear to you now. If I now tell you about the atom, we do have a rough idea about the atom. That atom is like this as of now because we just started the chapter. So atom is just simply assumed to be like this, that there is atom, the central part, it contains a nucleus, and in the periphery there is shells. In those shells we do have electrons, right? As of now we do know about the rough picture of atom to be like this. Although in your next chapter, that is structure of atom, it will be much more clear to you all guys. Yes, over here we do have nucleus, we do have shells. In the shells the electrons are present. So we do have a rough idea about the atom. Nucleus contain electron, nucleus contain the proton and neutron. proton and neutron. Together comprises the nucleon. Right? So if I do ask you about the further particles that are present in an atom, so we do name that as subatomic particles. That means Dalton told that only atom is the basic unit. There is nothing else than that. But we do know that atom do contain the subatomic particles. So from here we do get to know that atom do further contain the subatomic particles. Yes, ma'am. Subatomic particles are of in variety types like electron, proton, neutron, neutrino, antineutrino. They all are different type or. Okay. So, thank you Gautam Singh. Thank you beta. Okay. So here we are discussing about the concept of subatomic particles. There are n number of particles, subatomic particles, but over here we do discuss about the fundamental particles. Fundamental subatomic particles. Subatomic particles. So we do have three fundamental subatomic particles that are electron, proton and neutron. Electron is present outside the nucleus and proton, neutron is present inside the nucleus. All right. Yes, ma'am. Okay. Yes, ma'am. So here we do have the fundamental subatomic particles. Now let us discuss about them. Let us discuss about their properties, because in this chapter we must use the concept of fundamental particle to calculate the questions. Okay. Yes. Right now, beta, I am taking Arjuna batch. Further on, I will be taking their other batches as well. Right now, I'm done in your Arjuna batch. Okay. So, we will discuss about the subatomic particles now. You have to learn the values. I am here to help you out. First of all, we will discuss about the mass of these fundamental subatomic particles. So, proton and neutron, rough average are of same mass. As minute difference, whereas neutron is quite heavy than the proton, but you can take them approximately to be the same. Like proton and neutron approximate mass in kilograms is same only. But if I ask you about electron, electron is much lighter than both the two subatomic particles, which have the mass to be 9.1 into 10 raised to the power minus 31 kilograms. So this is the mass of electron, that is very low as compared to other two members. Yes, correct, ma'am. Then we are taking the mass in AMU. Now, ma'am, what is this AMU? I will teach you the concept of AMU. As of now, just consider that as the unit of mass, that is for very minute particles. Okay, so it is rough approximate to be 1, approximately equal to be 0. That means we don't consider the mass of electron at all. Approximate mass of electron is taken as 0 only. Okay, because it is very light in weight. Okay, moving on to the charges. But these are the actual charges that the particles carry. Plus for proton, minus for electron. Neutron carry no charge. Plus of 1.6 into 10 raised to the power minus 19 column. Minus of the same value that we use for proton. Just positive negative difference is there. If I relate them with each other, this and this relative mass is 1 only. Plus 1. Minus 1, and it is neutral. Neutron not carry any charge at all. So overall they are in an atom. Very nice, Charandeep. Very good, beta. So if I do ask you that overall in an atom, if the atom is neutral, so I do ask you that if the atom is neutral, the electron count is equal to the proton count, because electron is negatively charged and proton is positive charge. So overall they will balance out, cancel out each other's effect, and thereby making the overall charge to be same, overall charge to be neutral. Okay. Yes. Is this clear to you all? Yeah. So this is about the charge equilibrium, we can say neutrality. Thereby we can say that overall the charge is balanced. Okay. Atom is neutral because the electron count and proton count is same, thereby the atom is neutral. This explains us the electrical neutrality of an atom, that atom is neutral, beta. Okay, all right, ma'am. Now we will discuss how to represent an atom. What is the basic representation, right? So if I do represent an atom, I am just marking a symbol X for whatever element I am taking. For example, for hydrogen it is H. For sodium it is Na. For aluminum it is Al. For silicon it is Si. For carbon it is C. For oxygen it is O. For nitrogen it is N. For fluorine it is F. Right? For magnesium it is capital N, small g. You all are familiar with the symbols. Now, over to the base, we are using a term Z. Right? Z is over here atomic number. And A over here is mass number. Beta, this is mass number. This is not atomic mass. There is a difference. This is not atomic mass. This is atomic number. And this is mass number. So this is a basic representation that I am drawing over here to represent an atom in the terms of their mass number and atomic number. Right? Yes, ma'am. So this is the basic symbolic representation. Now moving on to the terms, atomic number represented by Z. So ma'am, how to calculate the atomic number? You just have to count that subatomic particle. Right now I told you what it was. It was proton. So the number of proton. Whatever the number of proton is there in an atom, that is your atomic number. Right? And I told you that number of proton is equal to number of electron only when the species is neutral. So in neutral case, if an atom is neutral, in that scenario, you do have the electron count and proton count and atomic number. All three are same, right? Yes, I will ask you certain question beta after this and you all have to answer me them. Okay, all right. Then moving on to mass number. Mass number represented by A. That will be equal to number of proton and number of neutron. So if I want to calculate the number of neutron, it will be equal to A minus P only. Mass number minus proton number only, and mass number minus proton, and I told you that proton and atomic number are same only, so I can write it like this, that the number of neutron are A minus Z. That means the mass number minus the atomic number. Okay, yes, very good. Okay, okay, is that thing clear to you all guys? Whether the concept are all okay to you all guys? Yes, everyone? Clear, everyone? Moving on to the question portion. Okay. So, we will calculate the electron, proton, neutron in different type of species here. Okay, beta? Yes. Then, I will tell you that, for example, I am taking an example of sodium. For say, I am having sodium, having the number 11, atomic number, and mass number as 23. And I am asking you to calculate the electron, the proton, and the neutron there in this species. But do let me know what is the number count you all are getting over here. 35, 70, electron, proton and neutron. What is the number count that you are getting over here? For nitrogen, if I do take an example of nitrogen, what is the number of electron, proton and neutron that you all are getting over here? If I ask you the question, tell me that how many electron, proton and neutron are there with your element sodium. As I told you that sodium contains the atomic number how much? 11. So the atomic number always be equal to the proton number. Right now I told you, don't forget the thing because this is very basic thing. That the electron, proton, see beta, the number of proton will always be equal to the atomic number. Will be equal to electron if the atom is neutral only then. If it is not neutral, then there is a change. Mass number is equal to the proton plus neutron. Right? Here the neutron will be equal to A minus P or you can say A minus Z because proton and mass number are, atomic number are equal only. Right? Yes, ma'am. So these are the different formulas that we will use over here. Since it is neutral, atomic number is 11. So proton will be 11 and electron will also be how much? Very nice. Kiran marked it right. Charandeep marked it right. I want my student to answer me like this only. I will teach you the important topics as well, beta. At last, I will tell you that when the session is near about completion, I will tell you, and parallelly as well, I will teach you that how many topics out of these are important. Now the topic, right now I'm telling you, this is important for your upcoming portion. If you don't know about it, you won't be able to solve the upcoming questions where this concept is required to solve those questions. Okay? Okay, neutron is the mass number minus atomic number, which is 23 minus 11, comes out to be 12 only. So this is how you have to answer the question. In case of chlorine, atomic number, beta, this is atomic number, this is mass number. Try solving the question, write it down there in the chat section. I am personally watching that who are giving me the answer. Right? Very good, Charan, very good, Kiran, very good, beta. This is how you all have to answer the question. If you are actually preparing for NEET, if you actually want to become future doctor, it is your responsibility to stay active throughout the class. It is your responsibility to keep on engaging yourself throughout the class by the chat section, because I also want my student to get their dream medical college. Okay, yes, beta. Moving on to the portion, electron comes out to be the proton number, that is 17 and 17 because it is neutral. Neutron number come out to be A minus Z. A minus Z. That means 35 minus 17. Right, beta? This is how you all have to answer the question. Right? Yes. So how many number you are getting over here? Neutron comes out to be 15. Huh? 15? 15. How come it to be 15? In this question. Beta, if I am asking you about the neutron, tell me. Yeah, 18. Okay? Yeah. Then if I ask you about this next, for nitrogen, it is 7 and 15 minus 7. 15 minus 7. Getting it out to be. Okay, so this is how you are getting the different type of subatomic particle depending on the formula that is given there to you. All right, that is clear to us, ma'am. Now, if I do ask you about what if the species contains a charge? There are two type of charges, students. There are two type of charges. No issue, not an issue. It is perfectly fine if you are now getting the answer that yes, ma'am, this is the solution of that question. My main task is to make you familiar with the different question that we will discuss there in the class. So if you are getting it, if you are able to solve it, you are now getting it, priorly did any mistake due to XYZ reason, that doesn't matter. Right now you know the concept, right now you are able to solve the question, that is perfectly fine then. This is my main task. Okay, yes, moving on to the portion beta. Charge atom. There are two type of charge atom. Positively charged atom. Tell me that positive charge is formed by the electron loss, the loss of electron, and negative is by the gain of electron. Gain of electron, right? So if a species gain an electron, it will get a negative charge. If a species lost the electron, it will get a positive charge, right? If one more electron is just removed out, it will get much more positive charge. On a similar basis, if it remove one more electron, it will get one more positive charge. Depending on how many electron it is removing, it will automatically develop a charge. Simple as that. That charge is positive, right? And if a species already contain a negative charge like this, and then it release a charge, then it release minus electron, that means it removes the electron out. Always remember, whenever any electron is removed out, it will get a unit positive charge. That means over to it, you will give a positive charge, right? So minus species will get a positive, overall it become neutral only. So this is how you have to, keep on revising the concept that how to distribute the charge to which species in which manner. Okay, yes, so this is how you have to distribute the charges. Moving on to the next, negatively charged particle. So here I do have the gain of electron concept. Let us say an element B element with a positive charge. Okay, first of all, I'll take a neutral case. If gain the electron, if take the electron, it will get a negative charge. If it gain one more electron, it will get a negative more charge, -2 charge. If it gain one more electron, it will get a -3 charge, and so on. And if a species force a B positive, If the positive gain an electron, it will get a negative. Positive, negative cancel out. So thereby we are getting a neutral cheese. That is simple. Okay. Yeah. So this is all about. Now if I ask you a question, if Mg2 positive is there, having atomic number 12 and mass number 24. This is atomic number, this is mass number. Do tell me beta, what is the what is the number of proton? What is the proton count? What is the proton count there in it? What is the proton count there in it? How many protons are there? How many electrons are there? And how many neutrons are there now? So proton will always be equal to atomic number. But that I told you, for electron, you must see that whether the species is neutral or not. Do tell me beta, how many electrons are there with Mg2 positive? Yes. How many electrons are there with Mg2 positive? Do let me beta. Electrons. How many electrons are there? How many electrons are there? Yes. So if I do ask you about electron count, so proton is 12. You are removing 2 electron because it is 2 positive. 2 electron are removed. So 2 removed minus 2. So always do the opposite thing as of charge. Plus is that you will do minus. Okay, you will get the 10 electron count over here. And for neutron, you just have to remove the AZ term like mass number 24, atomic number 12. You will get it out to be 12. Okay, so this is how you have to calculate the, depending on the species, that what species carries which type of charge. For say I do have O2 minus, okay, 18 and 8 over here. Now to tell me that what is the proton, electron, neutron in the species O2 minus with the 2 positive charge, 2 negative charge. Yes. So here we do have, for the student who didn't like the session so far, click the like button. I want to see the attendees over here. For whosoever joined the class first time that in this channel, don't forget to subscribe the channel, because we gonna cover all the chapters here in this channel only. You will get lot more content. You will get all the concept clear out, resolved out, all the concept clear out, resolved out there in this channel only. Okay, so don't forget to like the session and subscribe to the channel. Okay, moving on to the proton, electron, neutron count. So these are the number of electron, proton, beta proton. This is atomic number, this is mass number. Proton will always be equal to your atomic number, that is 8. And electron, 8 electron should also be 8, but since it carries a 2 minus charge, that means 2 more electrons are added now and you get total electron to be 10. While discussing about mass number, so mass number is 18 minus your atomic number. Yes, is 18 minus 8 comes out to be 10. That is the number of neutron. That's simple. This is how you have to solve any test type of question. Very simple concept, ma'am. We are very much clear about the concept now, ma'am. Right? So if I do give you some different type of species, let's say, if I do give you some different SO42 minus 4, here if I'm asking you about calculation of electron, proton and neutron. Electron, proton, neutron. So how to do so now? Firstly, I will teach you about the oxygen and sulfur concept. 4 oxygen, right? And 1 sulfur is there. Electron of sulfur. See, sulfur is which isotope of sulfur we can take, because nothing special mentioned over here. We do take the normal sulfur only. Okay. Similarly, oxygen is 8 and 16 only, right? So here proton is 16, oxygen 8, but since oxygen are 4 in number, so total oxygen number come out to be of proton 8 into 4. 8 is the number of proton. Since 4 oxygens are there, I am just multiplying 8 with 4. You are getting the number to be 32. 32 plus 16, total number of proton. Okay, 32 plus 16, you are getting it out to be 48. Okay, that is the number of proton. If I do ask you about the electron concept, so electron of sulfur, because it is having 16 electron only, same count 8 electron only, because proton electron is equal, you are getting it out to be 4 oxygen 32. But since it carries a 2 minus charge, that means 2 more extra electrons just added on to it. That means overall the number count come out to be 32 plus plus 16, that is 48, but you have to add 2 more electrons so as to get the number to be equal to the total electron count, because 2 minus means it carries 2 more electrons as compared to the neutral case. Is it clear to you now? Yes. Do tell me about the number of neutron guys there in the chat section. Here we have 16 and 32. So just subtract 32 minus 16. You are getting it out to be 16. And here 16 minus 8. You are getting it out to be 8. But since there are 4 oxygen, so I am overall getting the number to be 32 only. Right? 16 plus 32 comes out to be 48. That is the number of neutron. These are the number of electrons. So this is how you have to calculate the electron, proton, neutron count in any of the species that is given to you, whether it is single monoionic, it is polyatomic ion, it is monoatomic ion, whatever the case is. Okay. Is that clear to you all? Okay, everyone. Whether the concept is clear. If the concept is clear to you all, just like the button and do tell me that yes ma'am, the concept is super duper clear to us. My student usually tell me chamka there in the chat section when the concept actually strike them all. So whether the concept is okay for you all, just type chamka there in the chat section that yes ma'am, the concept is much more clear to us now. Now we can do any such type of question very easily with a very great ease, right? Right. Is the concept perfectly clearly or clear to you or not? Yes. Yes, clear. Okay, done. Okay. All right, let's continue now with another topic. That is some terms we're gonna discuss about the relation between them. Isotopes. Now, beta, what do you mean by isotopes? Isotopes are the species that do contain the same number of atomic number, but the mass number is different. For example, if I take example of hydrogen, 3 isotopes are there. Protium, deuterium, tritium. Atomic number is 1. Mass number is 1, 2 and 3. So atomic number Z 1, 1, 1. Mass number is 1, 2 and 3. And you all know that whatever the atomic number is, proton number is also the same. So we are having electron, proton and atomic number to be equal to 1 only. All of them contain the same proton. All of them contain the same electron. But if I ask you about the number of neutron, so the number will come out to be A minus Z, A minus Z, A minus Z. So yeah, here we will do 1 minus 1, that is 0, 2 minus 1, that is 1, 3 minus 1, that is 2. So neutron count is coming to be different. Neutron count is coming to be different. Right? So here we can say that isotope do have same atomic number. We already did have discussed this in our lower classes, ma'am. But number of proton is same, number of neutrons are different. Chemical properties same, difference in the radiation in the physical properties. And usually we do say that the heavier member, over here this is the heavier member. So the heavier member do have the difference from the rest of the member. Usually it is radioactive in nature. Do let me know bacha log in the comment section, what is the meaning of radioactive? What is the meaning of radioactive? Yes. Ma'am, the class is live daily. Please repeat, ma'am. We will be coming daily over the channel only with alternate classes beta of all the other chapters as well. Right now, I'm dealing there with chemistry. Yesterday also some live was there. Tomorrow also some live, like on a daily basis. There is live conducted there on this channel only. So if you all are new to the channel, just subscribe the channel, because on a daily basis, we're going to cover your backlogs. We are here to help you out with the free content over the YouTube channel, that is PW NEET English. Okay, so yes. Okay, moving on to the next concept, that over here, ma'am, what mass will actually will take, whether the hydrogen mass to be taken as 1, 2 or 3 then? We all know that hydrogen mass taken as 1 only, but that is not the actual mass. That is the average mass. So a new term is introduced, that is average atomic mass. So we will discuss about the term. I am asking you a question for all the students. Better do tell me, what is the mass of chlorine? I will see that how many of you actually know the mass of chlorine. Do let me know what is the mass of chlorine that you studied so far. Yes. Students, do let me know that in the comment section. What is the mass of chlorine? What is the mass of chlorine? What is the mass of chlorine? That you guys know. Thank you. Okay. What is the mass? I knew it. Class duration beta till 9. We will cover the session till 9. Overall, the class duration is of 3 hours. So, we will cover it till 9. Tell me. Tell me. Yeah. I knew it. I knew it. Many of you are stating me the mass of chlorine that you all have studied, that is 35.5. But let me make you very clear. Actually, no chlorine atom at all exists with a mass number of 35.5. That is just the wrong thing that you all have studied. Beta chlorine mass is never ever 35.5. It is just the average mass that you all study. Right? Actual mean chlorine chlorine do exist in two different forms, two isotopic form. What to be 35 number mass number, another one carrying a 37 mass number. Although the atomic number is same only, but these are two isotope of chlorine. So here, what to take, ma'am? 35 or 37? Which mass of chlorine to consider over here? So we usually use a term average atomic mass in that scenarios. When an element exists in isotopic forms, we do take the average. How? In which basis we are taking the average? We just do take the abundance of them. Abundance in the sense that we just take the percentage abundance, that how much abundant this particular isotope of an element there in nature. So if I do ask you about chlorine 35 element, so it is 75% abundant in nature and this one is 25% abundant in nature. Okay ma'am, clear ma'am, everything is clear so far. But if I do ask you about the average atomic mass, then average atomic mass is considered that we are taking the average of these two. How ma'am? Beta, here we can take the average just by taking the mass number of one element, one isotope, multiplying with its percentage, that is 75%, adding up with the next element mass number 37 with its percentage, like this. All right. So this is how we are taking the average atomic mass, by multiplying the mass number by their percentage and adding up all the isotopes, right? So this is how, yes, yes, okay, I am good, I am super duper good. Yes, I am teaching you that in over this platform only, beta. Okay, so thereby we can add them both up and overall we are getting it to be 35.5. So this is the average mass. This is the average mass. This is not the actual mass. No chlorine at all exists like 35 or 37. That is not true. Alright, so in these scenarios, we do take the average mass. Now, some other question frame up in a manner that average mass they have given to you and they are asking you about percentages for two elements, that mass number given to you. In that type of question, you just have to put the value x over here and this to be 100 minus x. Thereby you can find out the percentages as well. Depending upon the type of question, you can automatically change the framework. Okay. All right. Moving on to next, some isoterms that are here. We can say isobars. What is the meaning of isobars? Students, what is the meaning of isobars? Isobars are the one that do have the same mass number, but the atomic number is different, just opposite to isotopes. For example, argon and calcium. Here we can say that the mass number 18, mass number over here is 18, mass number over here is 20, but sorry, atomic number is different, but the mass number is 40 and 42 be same only. Isoelectrons means the one that do have the same number of electron. For example, your sodium positive, magnesium 2 positive, or aluminium 3 positive. We know that sodium contains 11 electron, but since it carries a positive charge, that means one electron is removed from the species. So it now contains 10 electrons. Similarly, magnesium 2 positive do contain 12 electron, but 2 positive means it removes 2 electron, it do contain 10 electron. Aluminium 3 positive contain 13 total electron, but remove 3 electron, that means it will carry the 10 electron only. So thereby we can say that species do contain the different type of electrons, same type of electrons, depending on the example given there to you. Okay? Okay, yes, everyone. Okay, perfectly fine. Moving on to next term that is very more important to you all, isospheres. Here the term tells us that isosphere contains those species that do have the same electron, also the atomicity is same. What is the meaning of atomicity? If I do ask you what is the atomicity of N2O, do let me know in the chat section what is the atomicity of N2O and what is the atomicity of CO2. Tell me beta there in the chat section what is the atomicity. Yes. What is the atomicity? What is the atomicity? Yes, correct. Absolutely correct. 3 atoms are there. 3 is the atomicity of this and this species. But if I do ask you about the number of electrons, so beta they are in N2. We do have how many electrons? 7 of nitrogen into 2 plus oxygen do contain how many electron? 8 electron. So there are overall total 14 plus 8. That means 20. 2 electrons are there overall with N2. And if I do ask you about CO2, that how many atoms, how many electrons this CO2 molecule do contain? 6 of carbon and 2 into 8 of oxygen. So 6 plus we do have 16. That means overall the number again coming out to be 22 only. So here we do have two species that do contain the same number of electron, same atomicity. So they are categorized as isospheres. All right, moving on to the next term, that is isotones. Tones, N means neutron. So here the neutron number is same. And how we do deduce that? Just simply subtract the mass number with this atomic number. 40 minus 14 and 31 minus 15. All right, so thereby you will get the number out to be how much? Beta, you will get the number out to be 26 and 26 over here. Right, so this is how you just have to find out that what is the number of neutrons you are getting over here, whether the number count come out to be same or not. Meaning of next term, that is isodiaphers. Now what is this isodiaphers term, ma'am? Isodiaphers means neutron minus proton difference is same. What is neutron minus proton difference? For example, this carbon 1361 structure, I do have neutrons. Firstly, we'll say the proton number come out to be 6 only. But for neutron, I do have 13 minus 6, right? 13 minus 6 coming out to be 7. So neutron minus proton, neutron are 7 and proton are 6. I'm getting the neutron minus proton term to be 1. Similarly, doing the same for nitrogen, I do have proton to be 7. I do have neutron to be 15 minus 7 beta. 15 minus 7 coming out to be 8. So neutron minus proton, that is 8 minus 7 coming out to be 1 only. So the difference of neutron proton is 1 only. So here we do have these type of isotoms. You might find the question there in your exam, NEET exam, that what is the relation between the two species, that is given there to you. Okay, all right. Okay, that is there. Till now, we do have discussed all the isotops. Is that thing clear to you all or not? Do tell me that in the chat section. And why I am seeing that students have joined the class, but many of the students didn't like the like button, didn't click the like button. Why is it so? If you are liking the session, I want my student to click the like button so that ma'am will get motivated. Obviously, we teachers, what do we want? We want our student to be activated, to be super energetic there in the session, right? Because if the ma'am is full of energy, full of motivation. So I want my students as well to do the same thing. I want my student to click the like button so that I can see that how many of you are actively participating there in the session. Right? I want you to answer me the question parallelly as well, because until and unless you don't answer the questions, you won't be able to understand the concept then. Because ma'am is solving the question, but ma'am want my student as well to solve the question, because we don't have that much time, right beta? We don't have that much time. Already many months are being wasted. We are done with this very narrow time now. And you know the competition level, you know the competitive part, you know about NEET 2026, right? So it's high time now to get motivated, to be back to our pace, to be back to our rhythm, so as to get the dream medical college, right? Okay. Yes. Okay. So if you are okay, please did that thumbs up high five emoji there in the chat section, so that I can see that yes ma'am, we are getting the concept. Yes. Okay, moving on to the next concept now. Fine beta. Moving on to the next concept now, that is atomic mass. Very, 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 very important. The portion that we did so far is just a part. Now we are starting another part that is very much important for upcoming portion, for the complete chapter. This is the main portion. Okay. All right. So atomic mass. What is atomic mass? Why we are using the term atomic mass? Mass of an atom is atomic mass, ma'am. Very simple. Because it is looking like very easy, but actually it is not. The atomic mass term was just introduced so as to make your calculation, because the atom, suppose this is the atom. If I ask you to weight the atom, you first of all have to find a weighing balance. From that weighing balance, you have to see that whether the weighing balance is good to go to find the measurement of atom mass or not, because atoms are very small in size. So we need a particular, we can say weighing balance, so as to take the measurements, right beta? So in a manner, we just have taken carbon atom, carbon 12 atom, having the mass number to be 12. We just divided it into further pieces. Okay, we just divided into pieces, 12 pieces. And I have taken, for say, this piece over a weighing balance. Like this. I have taken this piece over a weighing balance. So what is this? This is 1/12 of carbon having 12 mass number. So this is 1/12 part of carbon atom. Which carbon atom? The carbon can be 12, 13, 14 as well. So carbon taken to be the 12th isotope. Okay. So I have divided the carbon into 12 pieces. This is just the assumption. And I have taken 1/12 part of that and tagged it as 1 AMU. This is considered as 1 AMU. What is 1 AMU? What is AMU term? AMU is atomic mass unit. Just like kilograms, we are using AMU. I'm using AMU. AMU is just used to represent the atomic mass unit, the unit that you use to find out the mass of very small particles. Very small particles. We can't use kilogram for atoms. We can't use grams for atom, because atoms are very light. Right? So a decent unit is taken, just like we don't use kilograms for gold. Right? We use gram terms for gold. Right? On a similar basis, we do use AMU for microscopic, for very small particles. Okay. Yeah. So this is 1/12 of mass of carbon. And now whosoever mass I want to calculate out, I am taking to the other side of the weighing balance. This is how I am just comparing the two out. This is the relative atomic mass concept. This is the relative atomic mass concept, that I am taking the mass of element relative to the 1/12 of carbon mass. So this is relative atomic mass. This is relative atomic mass. Relative atomic mass is the mass of the atom, whatever the atom is, the actual mass, divided by, we are relating it, we are comparing it, that you are this much time intelligent from the another person, right? We do use these relative terms, right? That Sharma ji ka beta. I think that many of you are getting the concept now, right? Yes. right? So we do say that Sharma ji ka beta is this much intelligent, this much intelligent, this much intelligent. So that is the comparison, right? So in a similar basis, we do compare the atoms as well. We do compare the atom as well in terms of their masses. Okay. So here we are saying the relative atomic mass is how much heavier the element is as compared to the 1/12 of carbon 12. So what is 1 AMU here? 1 AMU is 1/12 of mass of mass of mass of carbon 12. This is basically 1 AMU, and also 1/12 of mass of carbon 12. Carbon 12 is 12 grams, but if I do take the mass of carbon 12 atom, one atom, this is 12 gram for Na. I will tell you that Na atoms, Na is what? Avogadro number. Na atom is what? Avogadro number. Avogadro number atom mass of carbon Na atoms mass comes out to be Na atoms mass comes out to be 12 grams. So for one atom, the mass of carbon one atom will be 12 by Na gram. 1 by Na gram. 1 by Na gram. 1 by Na gram. So this is the mass of one carbon atom. So I am just putting over here 12 by Na, that is the mass there in gram. So 12 cancelled. So 1 AMU beta will be equal to how much? 1 by Na gram. So this is the relation that I am linking the AMU unit with this gram unit. Right? Right everyone? Right everyone? Now 1 by Na is 1 by 6.02 into 10 raised to the power 23. We can write it like this as well. On solving it out, 1.67 in 10 raised to the power minus 24 gram. We can write it as this as well. And to convert gram to kilogram, you all know. We can write it as 1.67 in 10 raised to the minus 27 kilograms as well. So these are different types of unit conversion that we do use to convert AMU. We can link it to with gram. We can link it with kilogram. So this is how the conversion actually proceeds. This is the relation between AMU and grams that we will use in the upcoming portions as well. This is the basic terminology of mass number. Mass number is just different. Mass number do not have any unit. Similarly, relative atomic mass. Beta, this is again unitless. We do represent it as RAM, relative atomic mass. Mass of an atom, we are relating it with carbon 12 mass. So it actually don't contain any unit. It do not have any unit. It is actually unitless. It is actually unitless. It do not contain any unit at all. Okay. So whenever I do ask you what is the relative mass, atomic mass of carbon, your relative atomic mass of oxygen, you will say it as, ma'am, relative atomic mass is of oxygen is, let's say, 16. So it will be 16 only, unitless. All right. So this is about the relative atomic mass. Why is it so? Because if mass of atom taken in AMU term and mass of carbon 12 atom is taken in AMU term, unit will cancel up and you will get it out to be unitless. Is that clear to you all? Okay. Let me see. Ma'am, what is your name? Beta, tell me what is your name. Other students who are attending a session, you I guess know. मैं आप कहाँ? Okay. What is your name? Okay. So myself, Beta Gunjan Goyal, your chemistry teacher. You can name it by Gigi ma'am as well. Okay. All right. Is that thing clear to you all? I am just reading down your comments. Whether the concept is all clear to you or not, do tell me that in the chat section. Yes, ma'am, it is perfectly, clearly. The concept is all done from our end. We are ready for the next topic now. Correct? Okay. So this is about the atomic mass. If I do take the oxygen as reference, we can take oxygen as the reference, but 1 AMU with respect to oxygen by 1/16 of mass of oxygen 16 atom. We can take it like this as well. In terms of nitrogen, whatever element we can take, we just have to take that much part only as the mass number of it is. Okay. Okay. Yes. Now moving on to the question. Question portion is actual mass. Whenever the question arises actual mass of any particular thing, you have to state that in gram unit or kilogram unit, majorly in gram unit. All right. Okay. So actual mass of nitrogen. We already know that nitrogen do contain nitrogen atom. They are asking us. Nitrogen atom is 14 AMU. 14 AMU, right? But they are asking us that you can convert it in grams as well. So as I told you how to convert AMU to gram, dividing it by Na, it will be in gram unit now. You can write it like 14 into 1.67 into 10 raised to the power minus 24 in gram unit, like this. For molecule, you need to know that how that nitrogen actually exists. So nitrogen exists in terms of N2 structure, where it is diatomic. Two atoms of nitrogen comprises an N2 molecule. So we do have 28. 2 into 14, that is 28. So 28 by Na in gram unit, you can write it like this, or 28 into 1.67 into 10 raised to the power minus 24 gram unit, like this. So this is the actual masses where you are using it in terms of their unit. So as of now, we do have discussed about the relative atomic mass, that is unitless, about the actual mass that do contain the unit, right? Right? Is the thing clear to you all? Moving on to another term, that is for a molecule. Again, for a molecule, mass is compared for a molecule with respect to, on a side of a weighing balance, we do have taken carbon 12. With respect to that carbon 12, we are now taking the molecule on other side. And how much heavier the molecule is, that determine what the molecular mass of the particular molecule is. With respect to what? Again, with respect to carbon 12 only. Okay, so the same reference, just like the previous case, we did have taken over here as well. Okay. Okay. Yes. Okay. Right. Okay. So moving on to some example of molecule. Let's say H2. So what will be the molecular mass now? Actual molecular mass, I'm telling about the actual molecular mass. So for hydrogen, 2 into 1 plus oxygen 16. So I'm getting it to be 18. Now in terms of AMU, or you can write it as U for a molecule. U is another unit, that is unified mass. Okay. If I do take another example, let's say CO2. So carbon mass is 12. 2 oxygen are there. So 2 into oxygen mass, that is 16. So I'm getting the value to be total 12 plus 32, that is 44 AMU. Alright, you can simply write in terms of molecule, because molecule is molecule atomic mass, right? So molecule mass unit. So it is, you can simply write U. U represent unified mass. Unified mass. On a similar basis, if I do ask you about any other example, let us say H2SO4. H2SO4. So what is the molecular mass of this H2SO4? Tell me beta there in the comment section. I want you all to tell me that what is the molecular mass of this H2SO4. I want to see that how many of you know how to calculate the molecular mass. On a similar basis, to tell me about the molecular mass of C12H22O11 if you are done with the prior example. C12H22O11, this is the formula of sucrose. Sucrose do contain this formula. Other elements as other molecules as well do contain. Sucrose, that is basically a sugar that we do discuss majority times in your mole concept chapter. Yes, beta, tell me what is the molecular mass of H2SO4? 100? No beta, 100 will not be the answer. There is some correction there need to be done in your answer. What is the molecular mass of H2SO4? What is the molecular mass of H? Okay, yes. Aditya. Yes, very nice Aditya. Very nice Aditya. Sulfur mass is 32. Don't worry. 2 into hydrogen, that is 1. Sulfur is 32. 4 into oxygen, that is 16. Overall, by adding them all, you will get it out to be 98 in terms of U. All right. Okay. Similarly, sucrose, 12 into carbon, that is 12. 22 into hydrogen, that is 1. 11 into oxygen, that is 16. So on adding it up to, you'll get it out to be 342 U. Okay, in unified mass, U terms. So this is how you can calculate the mass of any of the molecule that is given there to you. And this is a very basic thing that you need to know before the next topic. Alright, I think the portion is very much completely clear to you. Try this as well, C6H12O6 for glucose. C6H12O6, try this and do let me know in the comment section. Beta, what is the molecular mass of C6H12O6 that you all are getting? So that was the picture about the molecules, molecule mass, atomic mass. That was a rough picture that we did. But the thing will be much more clear now. How we are using that term for the upcoming portion. So here we have, yes, okay. Is that thing clear to you all, beta? Students, whether the thing clear to you? Okay. All right. So let's continue now with the next topic. That is very important topic, that is mole. Now what is mole? Why we are studying mole? What is the concept of mole? What is this mole term? Whether it is mass? What is this mole? Right? Many of the students are just curious to know that what is the meaning of mole now. Right? So let me make you very clear with the topic that mole is the term that we use just like the other terms that we use in our daily life. Just like when I state you one pair, what is one pair? One pair is for 2 pieces, right? Right? 1 dozen is for 12 pieces, right? Up 12 pieces is for anything. They can be chair, they can be table, they can be apple, they can be mangoes, they can be whatever the thing is. If I state anything to be 1 dozen, automatically a number came there in my mind, that is 12. That means 12 of anything comprises 1 dozen. On a similar basis, 1 score is for 20 articles, 20 pieces of anything. 1 gross is for 144 article. On a similar basis, if I do tell you about 1 mole of anything, that means 1 mole comprises 6.022 into 10 raised to the power what? Raised to the power 23. So your aim should be not to get crorepati in your life, not to become crorepati, arabpati in your life. Your aim is to achieve that tag of molepati. So your aim is to get molepati. Molepati. Do you know the meaning of molepati? Pati. That is, you want to earn how much? 6.022 into 10 raised to the power 23 rupees. Right? So your aim should be very much high. Okay? So you want to earn, yes, one student is there saying the same thing, Bhavishya. You want to earn 1 more rupees. Yes. You all want to earn 1 more only, and you all have to put a lot more effort to aim that aim. Right? To get that aim, what you are aiming for. So your aim only be fulfilled when you are putting a lot more effort there in your daily life, right? Okay. Yes. All right. So yes, whenever I say you 1 mole of anything, that means this much quantity of particle they carries, right? So if I do ask you about 1 mole of oxygen atom, that means 6.022 into 10 raised to the power 23 into 10 raised to the power 23 oxygen atom. See, these particles can be anything. It can be atom, it can be molecule, it can be ion, it can be electron, it can be proton, it can be neutron, it can be anything, right? So it can be anything depending on what the mole stating us, right? So 1 mole of oxygen atom, similarly 1 mole of oxygen molecule. So now this oxygen molecule is given to you. That means 6.022 into 10 raised to the power 23 oxygen represent as O2 molecule given to you. Yes, beta. This is how the representation of oxygen is there in the structure. Similarly, if given to you 1 mole of nitride ion, that means 6.022 into 10 raised to the power 23 N3 minus ions. Right? If 1 mole of H2O given to you, that means 6.022 into 10 raised to the power 23 H2O molecules are given to you. Right? Right? Clear everyone? So this is about the mole concept. This is about the mole concept. This is about the mole term. That whenever anything is specified as mole, 1 mole, that means you always have to assume this much quantity of that particular thing. It can be anything. Irrespective of whatever thing is mentioned, it can be anything. Why ma'am we are using this much quantity only? Here the question arises. Now ma'am, why we have taken this term only, this number only? This number is stated as your Avogadro's number. Avogadro's number. Avogadro's number. Now many of the students might ask the question, ma'am, why is this number specified to be this only, not any simple number? Why they are making our calculation much harder, right? So this is something like you all have to know that why we are using this number only. Because see beta, over here I am taking a container, let's say. This container contains 12 gram of carbon 12. Carbon, I know about carbon. I know about carbon. Now I know the mass of one atom of carbon to be 12 AMU. Now the same mass in grams, because gram is the unit that I can easily weigh, right? So I have taken 12 gram of carbon. I have taken 12 gram of carbon. And in 12 gram of carbon, I have calculated the number of atoms. Because I know that one atom mass, the carbon atom mass, one atom carbon mass is particular quantity. So accordingly, I can calculate that how much carbon atom is there in 12 grams. Because one atom mass is clear to me. So here I can find out the number of atom. It contains 6.022 into 10 raised to the power 23 carbon atoms. I'm repeating it once again, beta, that we are taking over here carbon, 12 gram of carbon, so as to make the number to be equal. Because carbon one atom mass is 12 AMU. So I have taken on a same basis 12 gram of carbon 12. And I have counted the number of atoms in it. The number comes out to be how much? 6.022 into 10 raised to the power 23. Yes, ma'am, now clear to us. That is this number specified as 1 mole. This number specified as 1 mole, that is Avogadro number. So from here, we did describe the term 1 mole as the 1 mole. What is the mole term? Mole is equal to the number that are present in 12 gram of carbon 12. This is the actual definition of mole. What? That 1 mole is something that contains the atom as much as 12 gram of carbon contain. And 12 gram of carbon contain how much atom? This much atom. So this is the definition of a mole. Is the thing clear to you all or not? Have you ever think about the concept that, ma'am, why we are using this term only, this number only? Why not any simple number? Because we have to take it in the terms of 12 gram of carbon only. So that mass of mole is molar mass. That mass of mole is molar mass. That mass of mole is molar mass. So the definition, you all can check that. What is the mole concept definition? Amount of substance that contain as many particles can be anything, as there are atoms in exactly 12 gram of carbon 12. So the carbon 12 atom contain the atoms to be equal to the one that contain there in 1 mole. Is the thing clear to you all or not? Whether the concept is clear to you all or not? 6 point, can we use 6 of, yes, you can use, we need 6 just as a round off figure. You too can use 6 for your calculative portion to be much more easy. Yes, you do can use. For the students who didn't like the session so far, why are you not following the thing that ma'am asking you for? When the ma'am asks you that if you are attending the session, then it is your responsibility to hit the like button so that ma'am can see that yes, you guys are actually attending the session, you guys are actually motivated toward the session, you guys are literally enjoying the session. So ma'am request always come that always give me the answer in the chat section, and if you are attending the session, mark your attendance through that like button. Okay, yes. Okay, fine. All right, moving on to the portion now. Continuing the portion now. So we are having over here the molecular mass, molar mass term. Now, if I do want to find out the mass of 1 mole of oxygen atom, I know the mass of one atom. One atom is 16 AMU. But since I know we do have Na atoms in 1 mole, we do have Na atoms. Na atoms. Mass of one oxygen atom is 16 AMU. But if I want the mass of 1 mole, so 1 mole mass is, you just have to multiply it by Na, that is Avogadro's number, right? Correct? Absolutely right. So I'm getting this in AMU. If I want it in grams, so what I need to do? How to convert AMU to grams? AMU to grams, as I told you, 1 AMU is equals to 1 by Na grams. Remember? So I can simply put 1 by Na. Here we can put it 1 by Na divided by Na. So as to get it in grams, that means the mass will come out to be 16 gram. Is it clear to you all guys? Okay. Then moving on to the next thing, that is 1 mole oxygen molecule. Oxygen molecule is O2. O2 is 2 oxygen. 16 into 2, that is 32 AMU. The mass of 1 molecule. For Na, I am just multiplying it with Na. Now if I want it in grams, I can just simply divide it by Na. Na and Na will cancel with each other and I will get the answer to be there in grams. 32 grams. 32 grams. Okay, moving on to nitride. On a similar basis, you can calculate it for nitride and the electron will not at all impact any change in the mass. You can simply write it in the nitrogen manner only, that is 14 gram. Okay, no change at all, 14 gram. You can simply write it like this only. Okay, moving on to H2O. So we know that for single H2O molecule, 18 AMU is there, but just replace this AMU term with gram, you will get the molar mass to be 18 gram only. Okay, is that clear to you all? How we are getting the same value but with the different sign in terms of their molar mass. Okay. Is that clear to you all guys? So this is how we do use the mole term for our different species. Okay. Now we are on to a different topic now. See, two new terms arises there in the mole, that is gram atom and gram molecule and gram ion. Whenever this term is written there in a question, 1 gram atom. What is the meaning of gram atom? What is the meaning of gram atom? Meaning of gram atom is we are stating it as 1 mole. Gram atom is not like 1 gram of anything. No beta. 1 gram atom represent 1 mole of it. Getting it? 1 gram atom represent 1 mole of anything. Any atom. For example, if I do write it as 1 gram atom oxygen. What is the meaning of it? We are saying it as 1 mole oxygen atom. That means we do have 6.022 into 10 raised to the power 23 atoms of oxygen. Atoms of oxygen. And what is the mass of them now? Mass of oxygen atom is 16 gram. Na atoms. If I do use the term gram ion, that is another term. Molecule. We'll start with molecule first. That is 1 mole of molecule. 1 mole of atom. For example, if I'm taking the example of 1 gram molecule oxygen. So what is the meaning of 1 gram molecule oxygen, students? So over here, if I do ask you about 1 gram molecule oxygen, what is the meaning of it? Here we are saying it as 1 mole oxygen molecule. That means 6.022 into 10 raised to the power 23 molecules of oxygen. Molecules of oxygen. Molecules of oxygen, that is O2. These much O2s are there. We are not having O. If you want to find oxygen atom, so here one molecule contain 2 atoms. So these much molecule contain 2 into these much. That is 23 atoms of oxygen. And if you want to find out the mass of this, the mass will come out to be 1 mole oxygen molecule, that is O2. So what is the mass of O2, beta? What is the mass of O2? Tell me there in the chat section. What are you doing? Why are you not giving the answer correctly? Just try, keep trying there in the chat section. Be focused, stay focused. What is the mass of O2, students? Try in the chat section. I want you all to answer me. What is the mass of O2 over here? Obviously, the mass of O2 is, we can say 32. 2 into mass of 16, that is oxygen mass, comes out to be 32 grams. So this is the mass of O2 that we all are getting over here. Okay, this is how you have to solve this thing. There is a difference between 1 gram molecule oxygen, 1 gram oxygen, 1 gram atom oxygen, 1 gram molecule oxygen, 1 gram of oxygen atom. These all things are different. I will help you all out. So this is the thing that I told you so far. Okay, so if I ask you about 1 gram oxygen, that means 1 gram oxygen means 1 mole oxygen atom. So we are taking oxygen as an atom. That is 16 gram. If I do ask you about 1 gram molecule mean 1 mole of it. Of molecule. Molecule is O2. So I'm asking you about 1 gram molecule, 1 mole of oxygen molecule. Molecule means O2. So what is the mass of it come out to be? 32. Okay. So this is how you all have to solve the question over here. I think the portion is completely clear that why we are distinguishing the term, because this thing you all need to know. This is an important thing you all must have to get an idea about, because these type of things majorly come there in your exam and are quite confusing to make the negative marking very easy for you. Okay, so once the concept is clear, you all guys literally rock the session and will be able to do any such type of question whenever they ask. All right, we will do questions. We will do the question practice just after this only. And I want you all to be activated in the session, because you all have to answer me the question that I will ask you just after this slide. Okay, moving on to the topic. So first of all, tell me that in the chat section that whether all the things that I am dealing with are clear to you or not. But why are you saying these all type of things? Like you are just chatting there with each other on the platform and you are actually not focusing on the content. You all guys have to be focused there for your NEET examination. Otherwise, you know what the outcome will be. Okay, all right, fine. Moving on to mole relation. We now have the different type of formula that we use for calculating the mass from mole, the volume from mole. There are numerous number of formulas that we do use. Okay, but just I want you all to let me clear that in the chat section that whether the concept that I'm telling to you are clear or not. So I want you all to keep on typing that in the chat section, that whether the concept are okay to you or not, whether everything is clear to you or not. Okay, good, nice, fine. Mole relation. So mole, first relation is mole to mass relation. Mole to mass relation. That means we are finding the mass and mole relation. Let us say in a question they are giving you the mass and asking about mole. So you can use this formula. You can use this formula. Or they are asking about mass and giving you mole. You can use this formula. Then if they are giving you number, mass to number relation, mass to number relation. So there in the question, mole is equal to given particle. Now ma'am, what is particle? But a particle can be anything, as I told you, depending on the mole, that whose mole is given to you. Whether they are of atom, molecule, ion, whatever the thing is, that particle you will consider over here. It can be atom, it can be molecule, it can be ion, it can be electron, it can be proton, it can be anything. So given particle by Avogadro's number, that is Na. That is Na. 6.022 into 10 raised to the power 23, that you all know. Then the third relation that we do use is volume relation. Third relation that we do use is volume relation. Mole to then the third relation is for mole to volume relation. Mole to volume relation. So here we do use the formula mole is equal to whatever the volume given to you at STP or NTP. Now ma'am, what is STP, NTP? These are the special conditions, beta. I will tell you. So students, mole to volume relation is like given volume at STP, we are considering 1 mole of a gas at STP or NTP occupies how much volume? 22.4 liter. That is an approx value. It varies, but you have to use it in all the question, 22.4, right? So you can use the value to be 22.4 liter per mole. Okay, so here you can write it like this, gram per mole. Okay, so this is the formula that you all can use. Now since all of them are equal to mole, you can equate them as well. That mole is equal to, all of them are equal to mole. So if let's say in the question, particle given to you, mole they are asking, you can use the formula. Mole is given to you, volume they are asking, you can use this formula. Mass given to you, mole they are asking, you can use this formula. But what if mass they are asking you and they are giving you the particle number, molecule number or volume number? So you have to combine them all. Alright. So you can use the formula given mass by molar mass. Given mass by molar mass to be equal to given particle by Avogadro number to be equal to given volume by 22.4. This is how you can mug up these three formulas, combine these three formulas, and accordingly whatever the question they are asking you, whether they are asking you volume and giving you particles, they are asking you particle giving you mass, you can use a formula accordingly. You can combine these three formulas, make it a formula, complete formula, and accordingly you can find whatever thing they are asking you in the question. Okay, fine beta. I think that the portion is very much clear to you now. Right everyone? Right everyone? Clear everyone? Perfectly clear to all? Yes? Do let me know in the chat section that yes ma'am, the concept is clear to us now. And we are now jumping to multiple questions of the same concept so as to make the concept more clear to you. Getting on to the first question. Calculate the number of moles. They are asking about moles and giving you what? Mass. So number of moles is equals to given mass by molar mass. Given mass given to you, that is 5.5, and molar mass of CO2 44. Molar mass of CO2, you all know molar mass is 44 of CO2. Just calculate it out if you don't know. CO2. Carbon has 12. 2 into oxygen is how much? 16. So overall you'll get it out to be 44 only. 12 plus 32, 44 only. Right, beta? So this is how you have to calculate the molar mass, and overall you'll get the one answer of moles. Moving on to 12 gram of carbon atom. Now the atom is given to you. So given mass upon molar mass. Given mass is 12. Molar mass of carbon is also 12. You will get it out to be 1 only. Right? Clear? Yes, ma'am. Moving on to 12 gram carbon atom. It is not gram now. Don't get confused with the term. It is not gram. It is not gram. It is gram atom. I already told you that gram atom represent mole. Why you are confused with the topic? I already told you that whenever they are giving you gram atom, that means they are giving you mole of it. So 12 mole of carbon is the answer coming out to be 12 mole only, right? And they are asking us about mole. So the answer will come out to be 12 mole. 1.12 liter of CH4 at STP. CH4 at STP. CH4 at STP. So that means they are asking you about the volume term, right? So they are giving you given volume upon 22.4 at STP. So 1.12 upon 22.4. This is how you have to solve it out. Okay? In terms of volume, you can calculate the moles. Right, beta? So it will come at a 0.2. One second. Point. Like this. And 0.5. Okay? 0.05, sorry. Moving on to next, that is molecules given there to you. So here we do have molecules. So number of moles will come out to be molecules given to you, that is 3.01 into 10 raised to the power 23 divided by 6.02, Avogadro's number, into 10 raised to the power 23. It will be cancelled up there with each other and you will get answer to be 0.5. Is that clear to you all, guys? Whether the thing is perfectly clear to you all? Very nice, very nice, very nice, very nice. Very good. Keep it up. Keep it up, keep it up, keep it up. I can see over here in the chat section that many of the students answered me the question. Yes, the thing is perfectly clearly audible, visible. Yes, beta. Whether the concept is clear to you all or not. Do tell me that in the chat section. Whether I am perfectly clear to you all or not. Yes. Okay, everything perfect. We can shift that to next question. So we can shift that to next question now. Okay. Calculate the number of moles in each of the following. 6 gram of urea. Urea is what? NH2, CO, NH2. For the one that are unaware about the formula of urea, you all guys just fill the question. So for these type of questions, you all have to know the formula of it. Okay? You all have to know the formula of it. Otherwise, you won't be able to solve the question. 6 gram of urea given to you. Urea is like this. So the mass of urea is, if you do calculate, it will come out to be 60. So number of moles will be given mass, that is 6. Upon molar mass, that is 60. So 0.1 will be your answer. Okay, this is how you have to solve. On a similar basis, you can find out the sucrose C12H22O11. Similarly, you can do the question by your own because the molar mass of sucrose will be 342 now. Similarly, you can do for oxygen. Okay, now the oxygen, which oxygen, ma'am, do we have to take? Whether we have to take oxygen to be single oxygen atom or to be molecular form of oxygen, that is O2. So there the question arises that which oxygen do we have to take, ma'am? Right? Here we have to take oxygen as, K. Whenever it is not mentioned in the atomic form, you always do have to take oxygen as O2. So here mass given to you is 8 gram and the molar mass taken is of O2. So 2 into oxygen, that is 16. 8 upon 32. Right? So this is how you have to solve it all out and thereby you will get the answer to be 0.25. Is that thing clear to you all guys or not? I think the portion is completely, perfectly, clearly fine for you all. All right, fine now. Okay, shifting on to next questions. That is number of moles. Again, we have to find out. Again, for oxygen, what oxygen you have taken, whether it is oxygen O atom or O2, whenever they are giving you the question in terms of oxygen, consider it as O2 only in the form that it do exist. For nitrogen, N2 only, right? So you will be able to solve these questions, I guess. You will be able to solve these questions as well, right? Yes. Now I will do solve this question for you all guys. 112 centimeter cube of CH4. Now ma'am, what is this centimeter cube? We don't know about it. Beta, always remember the volume conversion. Volume relation. Volume relation. Volume relation. Now how the volume is related with each other? We do know that 1 meter cube is equals to 1000 liter. And liter and decimeter cube are just like each other. They are equal with each other. Decimeter cube with liter. Okay, I am making the concept much more clear for you all guys, so that you get to know that how we are relating the volume terms, because this is the thing that many of the students find very confusing. Okay, fine. Yes. Now we do have centimeter cube relation as well. We know that 1 liter is equals to 1000 ml. And ml is just like centimeter cube. Ml and centimeter cube are one and only same thing. You can write it as cc. Centimeter cube, cubic centimeter. So these all are the different volume conversions that we do use during the calculation of these questions. So it is over here centimeter cube, and right now I told you centimeter cube is just like ml. But in the formula of moles, you know that I told you 22.4 was volume in liter. So either you have to make both of them in liter term or to make them both in ml term. So if you are taking 112 centimeter cube or ml, you have to take 22.4 in terms of ml only. So I'm writing 22400 because 22.4 liter is equals to 22400 ml only. Right? So I have just converted it in ml per mole, and I am getting the answer in terms of what? In terms of your 200. So 0.005. Okay. Please upload lectures for all the question. Okay. Today I guess it is our first lecture of chemistry that we did in this chapter. So I want you all to stay active. If you all are requesting us, then definitely we're gonna cover all other chapters as well. But for that, you all have to be engaging throughout the session. It should be visible to us that you guys literally want the session from us all, so that not only we can bring the sessions. Okay. This is how you can solve. The rest of the question I want you all to do by your own, because I already told you the concept. So just try these questions maximum time, and do let me know that in the chat section after the session gets over. I want my students, whosoever is watching the session with proper dedication, whosoever is attempting the question, I want you all to do the homework question that I am giving that to you by putting a time stamp. That means over that time, ma'am has given us the question and we are solving the question, and this is what we are getting. I will personally, my team will personally read them all out, and we'll see that how many of you actually attempted the question. All right. Okay. Yes. Okay. Calculate the number of atoms. Now they are asking about the atoms. We know the formula, number of moles in terms of atoms. Particles, number of particles upon Avogadro number. Particles upon Avogadro number. So if I want to know the particle, it will come out to be number of moles into Avogadro number, right? Now particles can be anything depending on whose moles are you taking, right? So over here, if I want to count the number of atoms, moles of oxygen given to you, and we know that oxygen is like O2. So firstly, we have to find out the particle over here to be the molecule, because O2 is a molecule, it is not an atom. So in place of particle, I'm writing molecule. Molecule will come out to be number of moles, that is 0.5 into Na. That formula. I am getting molecule, but if I want atom, so how to get atom? In a molecule, I do have two atoms. Now if I want atoms, overall atom number, so I want molecule to be multiple of 2, so that number of atom can be obtained. So 2 into 0.5 Na. Beta, is the thing clear to you all or not? We always have to firstly calculate the thing given to us, that whether they are giving us the molecule, whether they are giving us the atom. Accordingly, we can calculate what they are asking us about. They are asking us about atom. And we know in one O2 molecule, there are 2 atoms. So accordingly, we just have to multiply the molecule by 2. That is the atomicity. Right? And we can get the atom. Right? Okay, fine. Then moving on to mole of oxygen atom. Now atom is there given to you. So atom will be equal to, in place of particle, I'm writing atom now. Number of moles into Na. Number of moles is how much? 0.5. So 0.5 Na will be the answer. Right? This is how you have to solve. Moving on to next question. Now 0.5 gram atom. And as I told you, gram atom means mole. Now whether it is oxygen or individually or atom or molecule. Tell me beta, whether this oxygen given to you, you have to write it in terms of O atom or O2. Now, since gram atom given to you, gram atom, that means this is atom. We have 0.5 mole of oxygen atom. So, accordingly, atom can be obtained by moles into Na, and moles is how much? 0.5. So, 0.5 Na will be your answer. Is that clear to you all? Yes, everyone. Yes, clear or not? Clear or not? Crystal clear or not? Fine. Then is gram molecule. See the difference. Oxygen now here in the form of molecular state. Because gram molecule doesn't mean gram. It represents the mole of that molecule. Right? So here we will just use first of all mole will be equal to number of moles, which is 0.5 into Na. But if I want atom, molecule beta, molecule will be equal to 0.5 Na. And if I want atom, so I do have to multiply it by 2 because one molecule contains 2 atoms. So 0.5 Na will contain 2 into 0.5 Na oxygen atoms. On a similar basis, 1.12 liter of nitrogen gas at STP. So again, now they are giving you what? They are giving you volume. So molecule nitrogen, see 1.12 nitrogen at STP. Nitrogen is gaseous. So you have to write it as N2 molecule. So here I'm writing molecule in terms of particle equal to number of moles into Na. But since number of moles not given to you, they are giving you volume. So you have to write it in volume term, like 1.12 volume at STP upon 22.4 liter into Na. So this will be the molecules. For atoms, you have to multiply by 2 to get the atoms, because this is molecules. And in one molecule, we do have 2 atoms. So if you multiply this molecule content with the 2, you will get the atoms. As simple. As simple. This is for all the students who are sincerely, dedicatedly listening there to me, right? For the students that those are not at all active, or those are not at all disciplined, not sincere, not you can say serious about the topic, this is not for them. But for the students who actually want their dream medical college, who actually want to score good, this session is for all of those. And the one that actually literally listening to each and every point will definitely get many more knowledge, many more benefit from this session. Okay, yeah. So 0.5 gram of oxygen, again oxygen is like O2. So O2 given mass by molar mass, number of moles will be, particle will be, particle is what? O2, O2 is molecule. Number of moles is not given to you, so given mass by molar mass, 0.5 is the molar mass, given mass, and O2 molar mass is beta 32. So this is the molecules, and for the atom you have to multiply by 2 and you will get the atom. So you will get the atom. Multiply the term molecule by 2 and you will get the atom count. Okay. This is how you have to solve these type of questions. Fine beta. Is the thing clear to you all guys? Moving on to next slide. Here, gram of sulfur. You have to solve this just like the oxygen thing. Here you just have to find out the atom. Atom is like 8 into the molecules count. And molecule will be how much? Molecule will be moles into Na. Moles is not given to you. Given mass by molar mass. So 3.2 is the given mass. And for sulfur 8. 8 into 32 mass, that is the molar mass of acid, into Na. By doing so, you will get the atom count, right? Oxygen atom given to you. So again, you have to find the atom by number of moles into molar mass. Number of moles is how much? How much number of moles are there? Number of moles are not given to you. Given mass is 8 by molar mass. So in place of number of moles, you will write given mass, that is 8, by molar mass, that is 16, into Na. This is how you all have to solve the questions. This is how you all have to solve the questions. Okay. Is the thing clear to you all, guys? Whether I am perfectly clear to you all, guys? Yes, everyone? Okay, everyone? Okay. Okay. Moving on to molecules. Again, you can solve the question. Molecules of oxygen. So atom is equal to the oxygen. 2 oxygen are there. So 2 into the molecules. Molecules given to you how much? 1.5 into 10 raised to the power 20. You will get the atoms. Right? On a similar basis, you can do other example as well. I will teach you this one. 52 AMU of helium. So 52 AMU of helium, you have to calculate atoms. If you know the answer, do tell me in the chat section. 52 AMU of helium given to you, and you have to find out the number of atoms. You know the atom is equal to, the particle equal to number of mole into Na. And since number of moles not given to you, in place of number of moles, you can use the formula given mass by molar mass, right, into Na. But since given mass is given to you in AMU unit, you have to convert it in grams unit. And as I told you, you can convert AMU to gram. So 52 into 1.67 into 10 raised to the power minus 24, you will get it in grams, divided by molar mass of helium, that is 4 gram per mole, and into Na. This is how you can solve it all out, and you will get the final answer to be accordingly. Okay, so remember to take the units accordingly, and then only you will be able to get the final answer to be correct only. Fine, beta. This is how you all have to solve the question. Moving on to these all are the question of mole. I already told you multiple times. One question is there of water ml relation. Okay, so for say you are asking about the mole present in 18 ml of water. So will you use the formula of volume? 18 by 8. What you will do then? Given volume by 22.4. No, students. You always have to think twice before attending any of the question, because this is very important thing. 18 ml of water although given to you, but they are not mentioning any STP condition, right? So here you have to consider the concept that STP is not given to you, so you can't use that formula of number of moles to be given volume upon 22.4. No, not at all. You just have to first of all convert this ml term to mass term. How, ma'am? Because you know the density of water to be 1 gram per ml. If you don't know, learn it. Density of water is 1 gram per ml. So accordingly, you can get the density is equal to mass by volume. Since this is 1, so mass and volume will be equal to each other. And since volume given to you is 18 ml, so mass will come out to be 18 gram only. So now you can use the formula of number of moles to be given mass by molar mass. So given mass is 18 and molar mass of water is also 18. You will get the answer to be 1 mole. Okay, so this is how you have to solve the question. But in the another question, 18 ml of water vapor at STP given to you. In this question, STP is written there. So you just have to use that volume formula. Okay, so here you can use the volume formula like number of moles is equal to given volume, that is 18 ml given to you. So given volume in liter, ml, you are taking it to be, let's say 18 ml by 22400 in ml per mole. So thereby you can solve the question, and accordingly you can get the number of moles in the formula. All right. Is this thing clear to you all? There is a difference between the two questions. Okay, by writing the STP condition, the answer changes. You have to clearly see that what thing they are asking you about, because this is very important concept. Multiple time they are in your PYQs. This thing they have already asked this thing in your NEET examinations. All right. Okay. Yes, Dr. Mehak, I can see that already the student named herself as doctor. So you are manifesting yourself to become doctor, and if you will do the practice to be like this only, you will definitely achieve what you want to be. Okay. Okay. So remaining question, I want you all to do practice the remaining questions and tell me in the comment section what is the answer you all are getting. All right. Students, whether the thing is clear to you or not. One mole beautiful. Okay. Fine. All right. So moving on. Okay. So we will try this question. What is the mass of carbon present in 0.75 mole of potassium ferrocyanide? If you don't know the formula of potassium ferrocyanide, K for FeCN6, then you won't be able to solve the question. So ma'am, now in these type of question, what to do then? If we don't know the formula, if we know the concept, then our question definitely won't be able to solve. We won't be able to get the number, right? So firstly, all you have to do in these type of things is keep on revising, keep on doing multiple questions. Wherever you are getting these type of things, like some special name you was not aware about, just revise them, like urea, like this name, right? So whenever they are asking you certain questions where a particular name is framed, just keep on revising them. If you do multiple question practice, with those question practice only, you will be able to get the name of a compound that they are asking for. Okay, so here we are having K for FeCN6. What they are asking, what is the mass of carbon? Carbon mass they are asking, present in 0.75 mole of potassium ferrocyanide. So here mole of this compound given to you, and they are asking about the carbon mass. So in these type of question, link the compound and the unknown thing with each other in terms of mole. Okay, so here I can say that K for FeCN6, one molecule of this K for FeCN6, potassium ferrocyanide, KFC लिख रही हूँ. Okay, no. Just write it potassium, K for FeCN6 only. Okay, contain how many carbon? Beta 6 carbon atoms. So I can say accordingly that 1 mole of this complex will contain 6 mole carbon atom only. And in question it is given 0.75 mole will contain 0.75 into 6 mole carbon atom only. And if they are asking about the mass of it, so how to calculate the mass? So if I want to know the mass, so multiply the mole with the carbon mass, that is 12. 0.75 into 6 into 12. You will get the answer in grams only. As simple. Right? This is how you all have to solve the question out. Very simple thing it is. You just have to link the compound there with each other, and thereby you will get the answer whatever they are asking for. If they are asking about the molecules, accordingly you can calculate the molecule. Once you get the mole term, you can find anything. You can find volume, you can find molecules, you can find mass, whatever thing they are asking you, because once you get the mole, you can link it with any other, you can say whatever they are asking for. Okay, fine. All right. Calculate the mass of CO2 which contain the same number of molecule as in 80 gram of oxygen. So the number of molecules are equating. Number of molecules they are equating of CO2 as in 80 gram of oxygen. Number of molecules in 80 gram of oxygen. That means what? Right? So the mass of CO2 they are asking. For the molecule relation there with mass. Remember molecule linked with moles firstly. Number of moles into Na. That is the formula for molecules. We have to link CO2 with O2. Number of moles into Na. And for number of moles, we have to write it like given mass by molar mass. Because mass of CO2 they are asking for. So given mass, I don't know. Right? Because they are asking us X by 20 44 CO2 mass is, CO2 molar mass is 44 into Na will come out to be equal to number of moles of O2. So given mass given to you, that is 80, and for O2 the molar mass is 32 into Na, right? So you just have to solve it all out. You will get the x term to be equal to 80 into 44 by 32 in grams. That is the mass. You have to solve these type of questions by just putting out the values, equating the equation of molecules, and accordingly put the desired formula. You just have to mention over. Okay. Is that thing clear to you all, guys? Whether the concept is clear to you all, guys? Yes, everyone. Do let me know that in the chat section. Whether, ma'am, the concept that was there in the question are all clear to you or not. Yes, 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 yes. What's your call? Okay, now I can see many of the students have joined the session, but I can see many of you haven't liked the session so far. If you actually getting the concept, if you are actually capable of getting the final answer, don't forget to like the session, because if you like the session, ma'am will be super motivated, and if ma'am is super motivated, ma'am will teach you very nicely, right? Okay. Yes. Crystal clear, ma'am. Okay. So this is how you all have to solve the question. All right. Calculate the mass. Okay, fine. Moving on to the next concept now. Calculate the mass of which contains same number of molecule. You all have to solve this question. This is homework question. Just like the previous question, this is also the same question. How many moles of magnesium phosphate contain 0.25 mole oxygen atom? See, magnesium phosphate Mg3PO4 twice. This is the formula of magnesium phosphate. They are asking us about how many moles contain 0.25 mole oxygen atom. See, as we know, 1 mole Mg3PO4 twice contain how many oxygen? See, we are having 4 to the 8. 8 oxygen. 1 mole will contain 8 mole oxygen atom. And they are asking us about how many mole. Like, we are unaware about the mole of magnesium phosphate, but are provided with 0.25 mole of oxygen atom. So you just have to link the two and accordingly have to find the value of x over here. This is how you all have to solve the question. Okay. Yes, 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 yes. So you just have to solve the question. You just have to solve it for the x value. So x value will come out to be how much? X will come out to be, ma'am, 0.25 by 8. This will be the x value, the mole of Mg3PO4 twice, magnesium phosphate moles, that will come out to be this much. So all you need to do in these type of question is max to max practice. For mole, if you want to excel in mole concept, you have to solve multiple questions at once, right? It will take certain time for you to get a quick recap of what the concept actually, applied there on a question. But after a lapse of time, you can easily solve these type of questions because you have practiced them. They're in your class as well. They're in the practice session. You're in your DPs as well. There are numerous practice sessions going on, right? So accordingly, you all will be able to solve these type of questions. Because I know many of the students find it difficult, right? Okay. Moving on to some other questions. Okay, so try this question. How much time in a year would it take to spend Avogadro's number of rupees if we spend 10 raised to the power 60 rupees per second? Okay, if 10 raised to the power 60 rupees are spent in 1 second, so 1 rupees spent in 1 by 10 raised to the power 60 second, and Avogadro number is how much? 6.02 in 10 raised to 23 rupees is spent in 1 upon 10 raised to the power 6, 6.02 into 10 raised to the power 23 second. So this is the period that you are getting, right? If you want to convert the second to accordingly in year, you know how the conversion actually happens. Second to minutes, minutes to hour, hour to days, and days to year. So this is how you will get the answer in year. Okay, is the thing clear to you all? Is the thing clear to you all? Very simple it was. Okay, these type of questions actually are very simple, but once you practice them, then only you find it easy. Okay, yeah. Moving on to chlorophyll contain this much percent magnesium by mass. Calculate the number of magnesium atom present in 2 gram of chlorophyll. Okay, so if we are having 2 gram chlorophyll, beta 2 gram chlorophyll do contain how much magnesium? 2 gram contain how much magnesium? Since we know the percentage of magnesium in chlorophyll, so we can accordingly find the mass of magnesium. That 2 gram will contain how much mass of magnesium? That 2 gram will contain 2 into 2.68 by 100 gram of magnesium. So this is the mass of magnesium that you got. Now you can easily convert that to number. How, ma'am? You all know about it, isn't it? Yeah, exactly. So here we can convert the mass there to number. How we can do so? So we can easily convert the mass to number. How? Number of particle magnesium atom can easily be calculated by taking the moles into Na. Since we don't know about moles, you can easily use the mass by molar mass relation. In place of number of moles, you can write it as 2 into 2.68 upon 100. That is the given mass divided by molar mass of magnesium. That is 24 into Na. You will get the number by solving the question. I'm trying this maximum question so that better you will get the concept that how these type of questions have to be solved, right? Okay, moving on to next question. Calculate the number of electron, proton, neutron in 4.2 gram of nitride. Nitride is nothing else, it is N3 minus. This is nitride. They're asking you about number of electron, proton and neutron. In nitrogen, I know that the proton count is how much? The atomic number, that is 17. 7. Atomic number is 7. So proton count is 7 only. And for electron, 7 is the number of proton. 7 should be the electron. But since it is 3 negative, that means 3 more electrons is accepted by over here. Nitrogen over here. So we are getting overall electron count to be 10. For neutron, I have to subtract this 14 with the 7. And overall, I'm getting the 7 number to be the neutron number. Right? So if they are asking you about the number type of thing there in the question, you have to calculate the molecules or the overall atoms, right? Overall atoms. Accordingly, you can calculate whatever thing they are asking you about. How, ma'am? See, 4.2 gram of nitride. So here you have to calculate the ions. Ions are the particles. That is number of moles into Na. Number of moles not given to you. Given mass by molar mass into Na, right? Given mass given to you, that is 4.2. And molar mass of nitrogen is 14 into Na. This is the ions. Number of nitride ions. Now, if you get the nitride ions, you can easily deduce the proton. How, ma'am? You can easily deduce the proton just by single ion contain 7 proton. These much ion contain 7 into the same quantity, that is 4.2 upon 14 into Na. On a similar basis, you can find out the electron by multiplying the same thing with the 10. On a similar basis, if you want to find out the neutron count, neutron are how much? 7. So on a similar basis, just like the proton, you will get the same number of neutron as well there in the question by putting the same values at all. That's it. Okay. Okay, is the thing clear to you? The question is clear to you or not? Yes, everyone. Do let me know whether the question is clear to you or not. This is how you have to solve. This is your homework question. The same question. Just for methane, you have to find the electron, proton, and neutron. Just for methane, you have to find the electron, proton, neutron. And whenever I'm giving you a homework question, I expect my students to do solve the question and tell me after the lecture end that what is the answer you all are getting in the question. Okay, by putting the timestamp, you all have to solve the question, and do let me know that in the chat section, in the comment section after the live end, that what is the answer you are getting in the particular question. Okay. Okay, clear, 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 clear. We can continue now with another question, another concept. Okay, so now are the conditions. NTP, STP, SATP, what are these? As I told you that NTP represent the normal temperature pressure, where temperature considered to be 20 degrees Celsius, pressure to be 1 atm. Whenever they mark NTP, always think about temperature pressure to be like this. Whenever they mark STP, standard temperature pressure, to be temperature 0 degrees Celsius, 273.15 Kelvin, pressure to be 1 bar, right? Now when they ask you about SATP, standard ambient temperature pressure, there you have to keep the temperature 25 degrees Celsius, pressure to be 1 bar only, just like STP condition. Okay, then is the some relations of pressure terms, pressure unit. You always have to remember atm and bar are almost equal to each other. 1 atm is almost equal to 1 bar, although relation is like this: 1 atm is equals to 1.01325 bar. Atm linked with mm of Hg, that is another pressure terms, that is 760, that is also equal to torr, right? Then we have liter atm unit related there with joule, energy units, right? So we can say that 1 liter atm is equals to 101.3 joule, and 1 calorie is equals to 4.184, approximately equal to 4.2 joule. You can say this as well. Okay, so these are the energy unit conversions that you all must need to know for the question solving of ideal gas equation. See, here we have ideal gas equation. Now, what is ideal gas equation? PV is equals to nRT is the ideal gas equation. P over here is the pressure, right? We can take it in atm. V is the volume occupied by the gas taken in liter. N is the moles, given mass by molar mass, given particle by Avogadro number, given volume by 22.4 at STP. You can use all those relations in terms of moles. R is the gas constant. Gas constant. And the gas constant values varies depending on the unit that you are using. Okay. And T is the temperature. T is the temperature that you use in Kelvin. Right. So this is the equation, ideal gas equation, that you usually use to solve the question whenever they are asking you about pressure, volume, temperature, or moles, whatever the thing they are asking and giving you rest of the things. You can simply use the formula. I will help you all out by taking an example to solve the question. Okay, related to ideal gas equation only. Right, students? Okay, everyone. Yes, very nice, very nice. Vineet, very good. Very good. Duration till 9. Half an hour is remaining, and till 9 session will continue, and after 9 we will end the session. Okay. Right now, okay, we were discussing about R. R is gas constant. So R gas constant value come out to be in liter atm, Kelvin inverse, mole inverse. We are having the value to be 0.0821. But when I convert that liter atm to joule, you know the relation 101.3. 1 liter atm is 101.3 joule. So you just have to put the value, convert the liter atm to joule term, right? By multiplying it by 101.3, you are getting the value to be 8.314 in joule, right? Then in the question, you have to see that which type of unit you have to frame according to the question. Then if you want that joule conversion in calorie term, remember the relation? Right now I told you 1 joule is equals to 4.2 calorie. 1 calorie is equals to 4.2 joule. That was the relation. So accordingly, you have to convert the joule to calorie, right? And you will get the answer to be 2. Rough average 2. So R do have 3 units that we usually use depending on the formula. Okay, fine. All right. So let us try the question. Okay, this is the question. Calculate the volume. So they are asking us about the volume occupied by 10 raised to the power 21 molecules. From there we can deduce the moles. Gas at 300 Kelvin and 700 mmHg pressure. So PV is equals to nRT equation we can use. Here we want to find out the volume. So pressure can be written as 700 mm of Hg. You can convert that mm of Hg to atm, right? By dividing it with 760. You will get the value to be in atm. Volume you want to know. Number of moles given to you 10 raised to the power 21 is the molecules by Avogadro number 6 into 10 raised to the power 23. You will get the molecules count. R is what? 0.0821. 0.0821. This is mole. 821 liter, atm, Kelvin inverse, mole inverse, right? Yes, ma'am. And temperature. Temperature given to you is how much? 300 Kelvin. So you just simply put over here 300 Kelvin, right? Just have to put the values. Accordingly, Kelvin, Kelvin inverse, mole get cancelled up, atm and atm get cancelled up, and you will get the volume in terms of liter only. Okay, you just have to solve the question and accordingly you will get the answer in terms of liter only. So volume will be there by putting the or solving the values, you will get the volume. See, my major task is not to solve the question. It is just to make you familiar with the concept that how the formula we just have to apply depending upon the different question that we obtain, right? Okay. Okay. Fine. Okay. So that is all about the ideal gas equation. Moving on to vapor density. What is vapor density? Vapor density is just the relation that mass occupied by VML of a gas. We are relating it with the mass occupied by VML of H2 gas. Okay, we are relating the particular gas vapor density. Vapor density of gas is what? It is the relation. We are taking the relation, we are linking the gas mass with its hydrogen gas mass. Okay, so here we are taking the VML of gas. Now, if I do take the mass of one molecule of gas divided by mass of one molecule of H2 gas. I am specifying the mass of particular V volume. Let's say I am taking a mass of V volume. Okay. And if I am taking it to be one molecule volume mass. Okay. So here I am specifying the hydrogen gas and I know the mass of one molecule of hydrogen as 2. So over here, vapor density of gas will come out to be the mass of gas. Mass of one molecule of gas is the mole mass divided by 2. So I can say over here, if I take mole over here, so molar mass. Okay, molecule is the molecular mass depending on whatever thing I'm taking. So we can say that molar mass of a gas is equals to 2 into its vapor density. So this is also the relation that we usually use there in the question, where vapor density is given to you, just have to multiply that with 2 and accordingly you will get the molecular mass. Okay, let us try a question on a similar pattern. Vapor density of gas is 22. That gas can be what? Okay, so if the vapor density of gas is 22, that means the molar mass is 2 into vapor density, that is 44. So you have to see that out of these, which gases do have the molar mass to be what? 44. If I ask you by a poll, tell me the answer, that what is the answer, what is the correct answer you all are getting. Yes. Okay, we'll see that what is the correct answer you all are getting. Try this with a poll, that what is the final answer you all are getting in the question. Yes, students, try this question. We'll see that how many of you are capable of trying the question. How many of you are Try. Keep on trying. What is the final answer that you all are getting? Okay, so I guess you are done with the poll. I think that we'll see. Okay, okay, I can see that students have not downloaded the app. You all guys have to download the app so that you can get the poll option. Right now, they're in the YouTube, you won't get that option, but you have to download the app. There you can click the answers and you will accordingly get the option. Now I can see that in the chat section that you are giving me the answer correctly, but you all have to, for this poll option, you all have to download the app, then only you can access the poll feature. Not worry, no issues, not an issue at all. So yes, CO2 do have the molar mass of 44 and N2 also do have the molar mass of 44. So both of them are having the same molar mass only. So there is the possibility of any of the gas, right? Okay, so here many more questions are there related to vapor density itself. Just like vapor density of a mixture of N2O and N2O4 is this. Okay, mixture. Okay, so mixture of NO2 and N2O4 given to you, and they are asking you about this mixture of it. How many moles of NO2 are present in 100 gram mixture? Okay, so they are asking you about the moles that NO2 contains. So see, here we do have 100 gram mixture, that is the, we can take the moles of them to be like this, right? So here we do have what? The moles of mixture, that is given mass by molar mass. Given mass is 100. And what is the molar mass then? Molar mass of mixture from the vapor density. So molar mass will be 2 into vapor density. So that means 2 into 38.3, right? And I can take the number of moles of NO2 and N2O4. Number of moles of NO2 will be given mass. Whether I know the mass, 100 is the total mass. So if I take the mass of NO2 to be x gram and molar mass of NO2, you can take the molar mass of NO2. How? Nitrogen mass to be 14 plus 2 into oxygen mass to be 16. Similarly, number of moles of N2O4. So if NO2 moles is given mass is x gram, I can take the mass of N2O4 to be how much? I just put the value over here, 100 minus x, to be the mass of N2O4 divided by what? Divided by the total molar mass. You can take it to be 2 into nitrogen, that is 14, plus 4 into oxygen to be 16. Accordingly, you can find out the value of x and you can find whatever they are asking you about. How many moles of NO2? That means overall you have to find out this value. Okay, so no need of open it up. You can simply write n number of moles of NO2. That is how you have to solve the question. Is that thing clear to you all? You just have to simply find out the value of x by putting all the values. Okay, so this is about vapor density concept. Moving on to percentage composition beta. Now what is percentage composition? Percentage composition is another term that is very important for finding out the percentage of any element present in a compound. For example, we do have H2O. So percentage of hydrogen will be how much? Mass of hydrogen, mass of hydrogen, mass of hydrogen in compound upon total mass, that is the molar mass into 100. So mass of hydrogen is how much? 2 into 1 upon total mass is 18 into 100. Similarly, if you want to find out the mass of oxygen, percentage of oxygen, either you can subtract it from 100, right? Either you can subtract it from 100 minus the percentage of hydrogen, or you can use the same formula for oxygen as well, that is mass of oxygen 16 and total mass is 18 into 100. You can find out the the percentage of oxygen. Okay, so there are different formulas depending on the requirement arises. That is, percentage of element is equal to the mass of element into the number of element. You can do one thing. You can use the formula percentage of element will be equal to what? Mass of element mass of element into the number of element, that in how much number it is present, divided by molar mass into 100, right? Yes, students. If I have taken, suppose, the number of element minimum to be 1, let us assume that at least single element is present there in the particular compound. Okay, so I am just changing the formula percentage of element to be equal to mass of element, mass of element, mass of element divided by minimum molar mass of compound, minimum molar mass of compound. See, these type of question might be asked there in your question paper in 200. We can use the formula to deduce the minimum molecular mass of the compound when they are giving you the percentage of element. Okay, we'll try it with an example. I'll give you an example. Okay, calculate the yes, this is the question. Insulin contain 3.4% of sulfur. So percent of sulfur given to you, right? Calculate the minimum molar mass of insulin. Minimum molar mass of insulin. So I am assuming over here percentage of sulfur, that mass of sulfur upon molar mass of insulin. Okay, insulin. So how to solve this out? Percentage given to you, that is 3.4. All right, minimum molar mass of insulin I need to find out. And I know the mass of sulfur, that is 32. So easily we can find out the minimum molar mass, that is 32 by 3.4 in grams. This is how you all have to solve it out. Okay. Yes, students. Otherwise, it will be very difficult for you to solve the question. You can use formula to ease up your calculation. Okay. Yes. This is how you all have to solve. And this is also again another question. Compound contain 20% nitrogen. So nitrogen percentage given to you. If one molecule contain how much nitrogen? 3 nitrogen. Molecular mass you have to calculate. So nitrogen percentage given to you, that is 20. 3 nitrogen given to you, that means 3 into 14. And you have to find out the molar mass. Right. So again you have to solve it out like this. Okay, 1 second. I have just skipped that 100, right? Into 100. Into 100. So thereby you can solve out the value. Okay. This is how. Again, another question, that hemoglobin contain this much amount of iron by mass. So percentage of iron given to you, that is 0.25%. Molar mass of hemoglobin given there to you, that is 89600. How many iron atoms? Atoms we don't know, but the mass of iron we know, right? So you can easily use the formula, put the values there in a formula, and you can easily find it out. See how easy it is just by using that formula. Are you getting it out? Yes or not? Okay, fine. This is how you all have to solve the relation. Moving on to the next topic, that is empirical and formula mass. Empirical and molecular mass. What is empirical mass? What is formula mass? How to solve the questions? See beta. We do have the molecular mass. Molecular mass represent the mass of the molecular formula represent. Molecular formula represent what? Molecular formula represent the actual atom that is present there in a particular compound. For example, we do have glucose formula C6H12O6, carbon 6, hydrogen 12, oxygen 6, right? But if you want to find out the empirical formula, empirical is the simplest relation, right? Simplest ratio between the elements of the molecule. Okay, so we can say that this complete formula is divisible by 2, right? And you can get the formula to be like this. So this is the empirical formula. This is the empirical formula. Okay, just the smallest ratio between the elements there in a molecule gives you empirical formula. Is the thing clear to you all? Now, if the question arises like this, which of the following pair contain the same percentage of oxygen? So, how to do solve this out? This is acetic acid, C2H4O2. If you do solve it out, you will get the formula, empirical formula CH2O. And this is also CH2O. In this question, again, CH2O is the empirical formula, and right now we did it. CH2O is the empirical formula. You can clearly see the percentages of oxygen coming out to be same in both of these. Again, CH2O, and this one was CH2 only. So we can simply clearly see over here that the percentages of oxygen is same in all of these, right? So we can say that all of them do contain the same percentage of oxygen, right everyone? Clear everyone? Okay. Now, other type of question they might ask that how to make a formula, empirical formula from different conditions given there to you. Either mass, either number, either volume. They can give you multiple things. You all have to convert them to mole version. Fine. Just like in this question, suppose we do have atom A, we do have atom B. Atom A contains, we can say how many atoms are there in A. 6 into 10 raised to the power 20 atoms are there, and 15 into 10 raised to the power 20 atoms are there of B. Now if I do convert that to mole, just divided by Na, I'll get what? I'll get moles, right? Dividing by Na, I'll get the moles. You just have to take the ratio of their moles. That's it. Just have to take the ratio of their moles. That's it. Okay, the simplest ratio of their moles, 20, 20, 3, 2, 3, 5, 2 ratio 5. This will be the empirical formula of the compound A and B combination we will get. Okay, so they are asking about the empirical formula. So you just have to deduce the simplest formula on combining the two A and B atoms, right? Okay. Class duration is till 9. Till 9. Okay. Silicon forms a compound with chlorine. Now here we do have silicon combining with chlorine. Percentages are given. No, mass is given there to you. 5.6 gram of silicon. So as I told you, convert that to mole. 5.6 given mass is 5.6, molar mass is 28. So I have written over here mole. On a similar basis, chlorine 21.3. 21.3, given mass is 21.3, and molar mass of it is 35.5, right? So this is how I have written the moles. You just have to deduce the simplest ratio. Now how to do that? Do solve this out. Find the minimum value. Whosoever is getting the minimum value, divide the both by the same value, multiply with the decent term, and you will get the simplest formula. You will get the simplest formula, and that will be the empirical formula. So I want you all to tell me there in homework that what is the empirical formula you are getting in this question. Okay, fine. Keep on trying. Do let me know in the comment section what is the empirical formula you all are getting after solving the question. This one. Okay, fine. All right. Moving on to the next concept, that is the stoichiometry concept. Very important, beta. This one is very important. So stoichiometry mean that they basically tell us, link us that what is the relation there between the species that are present in a particular reaction. How they are linking with each other. How they are relating there with each other. For example, we do have a case of N2H2 3H2, right? So we can say over here that one molecule of nitrogen do combine with 3 molecule of hydrogen and are producing 2 molecule of NH3. Or we can say 2 molecule of nitrogen combine there with 6 molecule of hydrogen and produces 4 molecule of NH3. I'm just dividing the same thing by 2, right? Multiplying the same thing by 2. Okay, yes, my molecule relation is clear. So we can say that Na molecule of N2, 3 Na molecule, 3 times of Na molecules of H2 combine there to produce 2 Na molecules of NH3. I can write it in terms of mole as well. 1 mole of N2 combine there with 3 mole of H2 and produce 2 mole of NH3. Right? Yes, ma'am. I can link them in terms of volume as well. 1 ml of Na react with 3 ml of, we can say V volume of Na and to react with 3 V ml of H2 produce 2V ml of NH3. Volume can also be linked, right? You can write in terms of volume as well, like 22.4 liter of this combined with 3 times 3 mole means 3 into 22.4 at STP condition and to produce 2 into 22.4 liter of NH3, right? So we can say it to be like this as well, right? But here always remember, never ever take it in terms of mass, like 1 kg react with 3 kg to produce 2 kg. No, not at all. This will never ever be the case. Never ever you can relate them in terms of mass by just taking the stoichiometry, the coefficient. So 1 ratio, 3 ratio, 2 is the ratio that you are getting by their reaction. But you always can take it in terms of number. You always can take in terms of volume, but never in terms of moles. You also can consider them, but never ever consider them in terms of volume, in terms of mass. Okay, so if I want to know that how much amount is produced from how much amount of reactant, accordingly I can link, right? If I do want to know that N2 plus 3H2 give rise to 2NH3. So if they ask you about how much NH3 is produced in grams from, we can say from 2 mole of N2. So you know that 1 mole N2, because the coefficient over here is 1, is producing 2 mole of NH3, right beta? 1 is producing 2 mole. So 2 mole will produce how much? 2 into 2, right? Mole of NH3. That means overall 4 mole of NH3 are to be produced. And you know the mole now. Now what thing they are asking you about? Whether they are asking about mass, you can easily deduce the mass. If they ask about volume, from volume you know the conversion. We already did it, right? So if you want the mass term, so mass of ammonia will come out to be mole into molar mass. So mole will be 4 and molar mass of ammonia is 17. So thereby you can multiply and you will get the answer to be there in mass terms. All right, is the thing clear to you all? This is how you have to solve the equations. This is how the concept are to be applied. Whatever thing they are giving you, the reactant side or product side, you just have to link them by the basic rules. Okay? Yes? Yes? Yes. I think the portion is completely clear to you all. Then there is a concept of purity. It is very simple again. Percentage purity tells us that percentage purity, how much pure the sample is as compared to the impure sample into 100. This is the question, like this is the formula that you use in multiple type of questions, depending on what they are asking you, right? Like in the question for say, in these type of question, 12.5 gram sample of NaHCO3 on heating gives itna amount CO2. Calculate the percentage purity of the sample. So how to reduce that? Now this mass given to you for the sample is impure. So on NaHCO3 heating, you will get Na2CO3, H2 and CO2. Okay, so you just have to balance it out like this. Forever, like whenever we have to solve these type of question, like stoichiometry question. For stoichiometry question, you always have to follow certain rules. Step 1 is to write the reaction. Write the reaction. Step 2 is to balance the reaction. Step 2 is to balance the reaction. And then you have to link them. Then you have to link them. Right? Just in this question of stoichiometry, you also have to do the same thing. How, ma'am? See beta, here in this question, they are asking you about percentage purity. The sample given to you is impure. The sample on heating gives 3 gram of CO2. That means 3 gram of CO2 is produced there in the reaction. So first of all, you have to write the equation. Yes, ma'am. Then you have to balance it. Yes, ma'am. After balancing, you have to link the relation. Link them with each other. They are asking about NHCO3, giving you about CO2. Just have to link these two. So 3 gram of CO2, that means just find out the moles. Given mass is 3 and molar mass is 44 gram per mole. So these are the moles of CO2. And you can see 1 mole is produced from 2 mole. 1 mole is produced from 2 mole. So this much mole will be produced from, so the NaHCO3 moles will come out to be 1 mole CO2 produced from 2 mole NaHCO3. So the moles of CO2 coming out to be 3 by 44 will be produced from how much NaHCO3? So 2 into 3 by 44. Okay, this will be the mole count of NaHCO3. If you know the mole, you can easily find the mass. You can easily find the mass. Mass will be number of mole into molar mass. Number of moles is 2 into 3 by 44. And molar mass of NaHCO3 is what? 23 nitrogen mass. Sodium mass. Hydrogen is 1. Carbon is 12. 3 into oxygen is 16. So this will be the mass of NaHCO3. Right, everyone? Right, everyone? You are getting the mass of NaHCO3. And this mass is the pure mass. If they are asking about the impure sample, what you will do? Percentage purity. Pure upon impure into 100. So you get the pure mass from this. Impure mass, you can put the values into 100. Percentage purity can be easily deduced. This is how you have to solve these type of questions. Is the thing perfectly clear to you all? I will take 5 more minutes of you guys. Okay, just to explain you the limiting reagent concept, and then we will done with the portion. Okay, limiting reagent. Percentage yield is another formula that we usually use. Just you have to percentage yield pure, we can say the obtained yield, practical yield from the practical, the one you are obtaining from the practical, theoretical yield from the theory that you actually calculate. Okay, the one that we calculate, that this is producing this much, so this much will produce how much, that is the theoretical yield. Okay, the product yield. Practical yield is what, beta? Practical yield is the one that we are getting from the experiment. They will give you, okay, into 100. So this is the formula that we usually use to calculate the yield. Now is the limiting reagent concept. What is limiting reagent concept? Again, a very easy concept, that is limiting reagent concept. Here we do have, let us say, different type of reactant reacting there to produce product. If we do have the information about both the reactants, right? So we can say that whether both the reactants completely utilize each other, right? Or one reactant is present in some excess quantity, so other will be in the less quantity. Just as we have to make a tea. I always do take an example to make a tea. Let us suppose we want to take 4 cup tea, want to make 4 cup tea from 4 cup milk only, right? 4 cup tea will be made by 4 cup milk only. But if you have, let's say, 3 cup of milk, sugar you have in huge quantity, so 4 cup milk are not there. We do have only 3 cup of milk. So here, how much quantity of tea can be prepared? We can say that in this situation, instead of 4 cup, we will be able to get only 3 cup of tea, right? Right. So here we can say that these situations create a reactant to be in limit quantity that will decide how much product to be formed. So here we do have a milk to be our limiting reagent. Limiting reagent, that is the one which is present there in a limiting quantity, right? So that is limiting reagent, and the other reagent is excess reagent. So the limiting reagent will always decide how much quantity of product will be created. Correct, students? Okay, students, is the thing clear to you all or not? Yes. So here we will say that A2 or B2 we react together with each other to produce C, let's say. Okay. So here, if I am taking the coefficient to be like this and C to be like this. So let us say in the question they are giving you that 4 mole of A2 and we are taking 9 mole of B2. Then tell me that how much C will be created. So here what you have to do, you have to find limiting reagent. Limiting reagent is calculated in a manner so as to convert this given mole by coefficient. Mole given to you are 4 and coefficient, that is the portion over here. Okay, so that is 2. On a similar basis, mole given to you of B2 are 9 and coefficient of it is 3. You are getting the value of it to be 2 and of it to be 3. So this one is your what? This one is your limiting value. So this is your limiting reagent, like A2 is the limiting reagent. Now they may ask you the question, how much quantity of C is produced and how much quantity of a reactant left behind. Okay, so here you have to find the remaining quantity in a manner like you just have to calculate that since you have this 2 value coming out over here, you have taken 4 moles, so just have to subtract 4 with 4 since limiting reagent will be completely exhaust. So you always have to keep it in a manner that you are getting the answer to be 0 remaining, because this is limiting reagent. It will be completely utilized. So always remember whatever quantity you have taken, subtract the same quantity. But from this one, that is 9 mole, you have to subtract how much quantity? The limit quantity, that is 2. So subtract this 2 and this is a short trick to get the remaining quantity. You are getting the 7 mole to be remaining one, right beta? But if I do ask you about the C produced, so the remaining limit quantity was 2. So just multiply this 2 with what? With the coefficient of C, that is 4. So 8 mole will be produced. 8 mole will be produced. 8 mole will be produced. This is how you can calculate that how much quantity of product is produced and how much quantity of reactants are remaining there in a reaction. This is very simple, very simple. This is making your calculation to be much more easier without using that link relations. Okay, so this is how you can easily do the question by just getting that idea that which one is limiting, that value you have to subtract from the other reagent and that value you have to multiply from the coefficient. You will get the product produced and you will get the remaining molecule that are left behind. Okay, on a similar basis, just try this question as well. Just try this question as well. I'll see that how many of you are capable of solving this question on a similar basis. Just like the previous one that we did, you again have to do the same question. How many product is formed, how many moles of product is formed, how many reactants are left behind, who is excess reagent, who is limiting reagent. You just have to tell me the same thing. Okay, so this is all you have to do, and that is all. On a similar basis, try this question as well. There in your homework. Apply the same concept just like I told you. Try solving maximum question. That is all from my end, and I hope the concept is much more clear to you now. Do let me know there in the comment section. I have given you a lot more homework, and all you need to do is just to practice and keep on practicing the concept. Okay. Ma'am, what will be the mass of 112 carbon? Where's the question? Okay. All right. So that is all from my end. I guess the session was all okay for you all guys. Any doubt, any query, anything you want me to tell that you are having problem in, you can ask the question. Yes, beta. All okay? So just try the questions. I guess the session was all okay for you all guys. You tried maximum question. You have given the answer there to me in the chat section, and you all were so amazing throughout the session. And I want you all to keep on practicing the question that I have given to you. After the session end, I want you all to answer me the question and also update me that how was the session for you all, whether you were able to find the concept much more easy now, you were able to solve the question now or not. Okay, so that is all from my end. Okay, yes, for all the students who are new to the channel, don't forget to subscribe it, don't forget to like the session, also to share the session there with your friends as well. Yes, because we gonna take multiple session there in this channel itself on a daily basis, on a regular basis for you all, so as you all can be active there for a particular topic, whatever you are demanding for. Whatever topic you want us to bring, just comment down, just pin that down, and we will bring that topic for you all, beta. Okay, thank you so much. Ma'am also enjoyed the session, and I want you all to give a feedback to me after the session, and I will personally read them all out and will try to comment them back. So after the session end, do let me know how was the session for you all guys. Okay, that is all from my end. Bye bye, take care. Okay. Bye everyone. Have some rest, take some rest, and we'll see you there in the next coming class with another chapter. Whatever chapter you demand, we will bring that chapter there for you. Bye everyone. I can see 95 likes over here, and I want you to make it 100 plus. Okay, so bye everyone. Take it. Okay.